come up with cool questions, but if there's not like a well-known solution to it, it might be difficult for me to get. Like some things are like unsolvable. Like the 3-body problem. That thing's not solvable. All right, let's make sure that's working. Good, now my YouTube chat's working. Nice. How come there are pulleys and no pushies? No. Sounds like something like, well, why are there no uppies and just downies or something? I don't know. All right. So Otis said, say there's a point attached to equally spaced pulleys on a wall. There's a machine that rolls the strings at a constant pace of the pulleys up to create tension force. Now grab the point and move further and further from the wall. Is it harder or easier to move the dot away from the wall as time increases? So yeah, I'm a little confused by like the equally spaced pulleys. Like what? Excuse me? Wait, what? What's going on here, Otis, by the way? Theta non equals theta 1 equals theta 2 equals theta n. I understand that. Yeah. I get that. Well, and also equally spaced by angle, right? If this was a wall, for instance, and these are equally spaced in this direction, they're not going to have the same angular displacement, right? Right? This one and this one is different than this one and this one. Especially as you get further out, right? If you have like two that are like way out here at like infinity, the angular displacement there is going to be like super, super tiny, right? Look at that. It'd be a really tiny angular displacement. Venchi, submit a screenshot. That's what all you have to do is submit a screenshot. Use the website, submit a screenshot. That's all you got to do. It's very easy. Watch what everyone else does. I know you're in school, Venchi. You just go find something that you're doing in school, and find a screenshot of it. And then he said, "Is it easier or harder to move the dot away as time increases?" There's a machine that rolls the strings of the pulleys up to create a tension force. Are those thetas indexed? Yeah, I feel like they are. This is a student just came up with this. They like came up with like a little thought experiment. I'm just a little confused about what they're even asking. What's up, Dojo? And then why is there tension? Why is there tension in the rope? It means that there must be some force pulling it back. Oh. Like, in order for there to be tension in a pulley, you have to have some force acting at the other end of the rope that's causing it to not want to move. Yeah. There you go, Venchi. Yeah, use the website. Use the website, Venchi. There's a website. Do you only do math and physics? No, I do all sorts of science, Xylox. So, chemistry is totally valid. Stats. I've done a lot of stats. Some engineering, as long as it's not, like, super involved engineering. Like if we start getting into like weird engineering terms for like it's blocked for you because of parental controls. What do you mean? How's the website blocked by parental controls? There's nothing wrong with the website. Okay, I'm gonna maybe punt on this question because I don't actually understand it. Otis, you have to come by and like actually explain this to me. I can't understand what the text. All right, let's see. Again, if you want us to go through your question on the stream here, there's a website for it. It's very easy. It's actualofficehours.com. And then all you do is put in your username, drag in a screenshot, hit upload. Venchi's having some issues. WCPSS. Okay. Sure, this is a valid question, Venchi. I'll count this one. Yeah, that's okay. I'll upload it for you, so I'll show you how it works. I'm confused how you can't go to websites. You have plenty of websites up on your tabs. How can you not go to our website? Next 4 questions are fairly easy. Love it. Where Where's my... dude, what is it? This? I have a hot queue. I swore I had a hot queue for snipping tool. There it is. Oh, well, why don't you just use your school computer then? Whatever you're using to get to this website is probably fine. Okay. All right, but I'll show how this works. So, for instance, this is the website. What you do, you just upload in a screenshot. I'm going to put in Vinci's username. Anything related to games? I don't think there's anything here related to games. What? What is it related to games on this? You hit upload. And then it'll say, nice, your screenshot's received. And then you can click here for view queue. And then this will show you all the questions that are in the queue. And you can click on anybody's username. And it'll come up. And you can see what we're doing. Or they just feel like blocking it? Oh, okay. Well, whatever. Math is adult entertainment. What's up, Star Prod? Alright. Let's see. Alright, let's see. Let's do this one. This one looks like some cool little math. Alright. If x and y are positive real numbers with 1 over x plus y is equal to 1 over x minus 1 over y, what is the value of x over y plus y over x squared? Ooh, fascinating. Oh. Well, Vince, you have to be here for me to do your question. You can't just, like, leave it. You can't just leave it and drop. What? Okay, cool. All right, come by next time. You're fine. All right. Good luck on your test tomorrow. It's due on Thursday? Well, I mean, today's Monday. Okay. What's the value of that plus that? Do you think we, like, want to expand this? Is that kind of what I want to do, maybe? So what? X squared over y squared plus partial fractions. Ooh. You think you want to do partial fractions with this? Y squared over x squared. I love integration. Integration is cool. Yeah. You want to do partial fractions with this. Okay. Oh, I see. Because that would be something over x, something over y. That is brilliant, actually. Yeah. Smart. Smart. What's up, Obi?
Good job.
Good to see you, Obi. Big shout out to Obi. Nice. W raid. Okay. Yeah, wait a minute. Partial fractions. That would only really help us here. Oh, sorry, I got rid of this. Damn it. You read Alex Kontorovich's treatise on diamond open access journals. You know Ghislaine Maxwell's, you know, the person who's involved with all this Epstein stuff? Her dad is what is responsible for all of these paywalled academic journals.
You done messed up, Aaron!
Whatever his name is, something Maxwell. Yeah, he was actually kind of a bastard. Yeah, maybe. Here, yeah, I think, again, I don't know if partial fractions... Yeah, he got some banger lines in this. Yeah, let me put this together. Well, you could put this together as a fraction, right? Yeah. So 1 over x minus 1 over y. In order for them to have the same denominator, right? You multiply this by y over y. You multiply this by x over x. And then that would just give you y minus x over xy. And then you say that is also equal to 1 over x plus y. This is cool. I see a difference of squares, maybe. Right? Because this is the same thing as 1 over y plus x. And then if I cross multiply this, right, then I get y minus x times y plus x is equal to xy. And anytime you have a minus b times a plus b, that's a squared minus b squared. So then this is y squared minus x squared is equal to xy. Okay. Maybe this would help to then expand this. Oh, cool. You got an archive link for me? Here, I'm going to pull that in. Cool. I'll read this up later. Thanks, Obi. Can you solve for x or y? I don't know if you can. I think what's going to happen is... well, I actually don't know what's going to happen. But let's try expanding this out. So this is x squared over y squared plus y squared over x squared plus 2xy over yx, right? Which Alistair was right. Yeah, so in expanded... I agree, Alistair. So this cancels. So then this just gets us x squared over y squared plus y squared over x squared plus 2. Do you like English? I mean, I speak English, so yeah, English is pretty dope. So this is known. But then the question is like, what is this equal to? My gut instinct is to try to modify this to look like this. We already have a squared in there, which is nice. If I end up as department chair someday, I'm definitely going to offer up 5 hours a week as service to the college for refereeing papers for a diamond OAJ, I swear. Oh, I see. Oh, I see. So this is a free journal is what you're saying. But I guess the issue is that they don't have any money. Right. Right. Yeah. Because article money is usually provided by some sort of grant. What's up, Leet Mage? Yeah, I got you, DMs. Add both sides for the known one, maybe? Yeah? Hydraulics problems? No. I can't do hydraulics. I can do math. Right. Yeah, I mean, but isn't that just what Archive is? Archive is free to readers and writers. I guess there's just no review panel on it. There's no referees. You have to pay referees money at some point, right? Somebody has to sacrifice their time to do things. It says I made a trigonometry short as my first vid. That might be true. I think my first YouTube video, Triofloor, was actually about foiling, which is kind of related to what we're doing here, honestly. Yeah. Peanuts. Oh. Well, what do they do with all the money, dude? Just like throw massive cocaine parties? What are they doing with all the cash? Let's divide both sides by something, right? Oh, man, I don't like that this is a minus. Because if this was a plus, then we'd be good. We'd be rolling in the dough, as we would say. Okay. Maybe. Yeah, that's always the joke, Obi. Grant money is it's like it's like Oracle, OpenAI, and Nvidia. They just keep sending each other money. It's just this circular imaginary money. Yeah, no, that makes sense, Obi. Service to the the service is supposed to be teaching, I guess, usually. No. This is not a typical algebra question. This is a tricky. This is what we call like a math competition question. This is a tricky one. Put the right side over a common denominator except for the 2. Square the left equation and solve. Okay. Okay, I kind of like that. All right, let's do it. All right, good. Let's do it. Thank you, Polymath. So you're saying let's do this like x squared over x squared, and then this is going to be y squared, y squared. So what do we have? We have x to the 4th plus y to the 4th over x squared, y squared plus 2. And then you want me to square this. I actually kind of see something here, maybe. Going to that counts as service to the university, just handing out water. I think, Polymath, I think you're on the right idea. You're like, let's square both sides here, right? So then what do I get? I get y to the 4th plus x to the 4th, which is what we have here, right? And then minus 2x squared y squared is equal to x squared y squared. So it's actually pretty cool, right? Oh, fuck. Oh, wow. This is brilliant, actually. Wow. Wow. This is really cool, actually. Yes, because watch. Now I divide this, right? Let's just divide it. So then I get y to the 4th plus x to the 4th. You have an integral? Submit it to the website. Website right there. Actualofficehours.com. I'll help you out with it. Right? Oh, this is super brilliant. Wow. Thank you, Polymath.
Oh, yeah.
I don't know how I didn't see that. And then this is equal to 1, right? If we move that underneath. Ah, bingo bango. Okay, cool. So then we have x to the 4th plus y to the 4th over x squared y squared minus 2. Oh, wait, fuck. It's minus 2, though.
Huh?
Man, I need it plus 2, though. Oh, I think it's okay, though, right? Yeah, wait. Okay. Is equal to 1, but then I can move this over, right? So this is just equal to 3. Okay. I wanted it to be, yeah, almost there. Bingo. Okay, so then this, right, yeah, okay. Now we know this is equal to 3. So the final answer is equal to 5. Nice. That's dope.
Oh, yeah.
I think it's 5. Did I mess up basic math? Yeah, cool. Yeah, or you could add 4 to both sides, Dojo. Yeah, right, nice. Cool, very cool question, Shantrix. I like that one. That was a fun one. Thank you, Polly. Yeah, that was tricky, honestly. But, again, I have the best community and, like, people in the audience and stuff. You guys help me out. I really like it. I really appreciate it, I guess. But that was Shantrix's question. So thank you, Shantrix, for that. That was cool. All right, here we go. Shantrix. Again, so if you're watching us right now and you want to know, hey, how could I get my question up on the stream? The way to do that is to go to the website here, actualofficehours.com. Well, where is it? There you go, actualofficehours.com. You type in your username, drop in a screenshot, hit upload, and then you'll see it come up on the live queue here. And then, why are none of my back buttons working? Sorry, what? And then I highly recommend that you go join our Discord, because every question I do today on the streams is going to get put into our Discord. So here, if we go to, where is it? It's like the homework help channel. Oh, wait, I gotta, yeah. This was Shantrix's question, for instance. And then all I'm going to do is I'm going to drop in the screenshot of what we did. So there it is. Ex-math prof here. Very cool, Polymath. Where did you teach math? Or what did you teach? Was it high school, college? And then everyone who submits a question gets like points for submitting questions. So appreciate it. Cool. All right, let's see what's next on the queue. Yes, to be Dojo is correct that, yeah, in this question we did, there is also the argument that, right, x and y cannot be 0, and then x plus y cannot be 0. Oh, University of Northern Illinois, nice. That's cool. My sister lives in Chicago, so I go to Chicago a lot, which is kind of Illinois, right? All right, let me see. Is DMs here? Where's Blue? Blue said he had to go do something. Agree or disagree? Writing exponential functions. All right, let's pull this in. Oh, neat. We back, chat. I'm watching the Steelers game. Ooh, oh yeah. Dude, my poor Eagles lost last night.
You're not that guy. You're not that guy.
To be honest, I mean, we were playing like ass, so it's okay. I understand why we lost. What's up, Triflor? Okay, explain stuff sucks for me. All right, that's fine. Let's do it. So it says, study the examples, determine whether you agree with each statement. It says, this table represented by the function b of x equals 3 times 2 to the x, where x is the day, and b of x is the number of cells by the thousands. Okay. And they want to know whether this agrees. Last two only per question. So yeah, one. I mean, this is just a thing generally. In general, yeah, I know proofs are kind of difficult for people, right? Like, you hate proofs. Like, how do I prove it? Like, 2 + 2 = 4. Duh. One of the logic in and of itself is a very cool topic because it helps us understand, like, the framework for what we determine truth to be. Like, what's right and what's wrong. One of the ways to disprove something is we say, like, disproving by contradiction, which means if you can find a case where the statement that they say is incorrect, then you can say that it's false. So here, they're saying that b of x is 3 times 2 to the x. So if you want to disprove this, an easy way to do that, and this is what you did here, is just pick one. So I think what you want to do, though, is you want to say, like, what x would be. Oh, he said I need help with the last two. Why? Yeah. I also wanted to, like, just, like, kind of show where this one comes from, because then we'll do the last two. Thank you, Jeff. Because also, wait, in this one, I think you want to be a little bit more clear here. You want to say, you don't want, like, just writing this is kind of confusing. You just said b of x is equal to 3 times 2 to the 2. You want to say this as b of 2. No, thanks, Jeff. I appreciate for you keeping up with me. But, yeah, so here you can say, like, let x equals 2. Because if you just write this, that's technically wrong. Right. Yeah. So, and you can show that, well, it would be 12, Dojo, because it's 3 times 2 to the 2. 3 times 4, which is 12. Yeah, it's okay, yeah. So, yeah, just make sure you just say b of 2, because otherwise, yeah, you look at this, you're like, wait, what case are you using? Yeah, all good. Okay, this function represents this after t with that being 0. So yeah, I guess you could check all the cases. That's one way, I guess, to explain your reasoning. Sure. You should show the first one though, right? So I would say, like, v of 0, right? That's equal to 6,000 times 0.85 to the 0. And anything to the 0 power is just 1. So then that's just the original value. Another way you could do this is this represents that the next value is always 85% of the first one. Right? So what you want to show is that, like, is 5,100 over 6,000, is that equal to 0.85? Because that's what an exponential function is, right? Exponential functions, are of the form, usually, like, a is equal to a naught, and then it's equal to r to the t, right? And then this is I think like the common ratio is what we say. Calc 2, you're not cooked. Calc 2 is easy. I like Calc 2. Calc 3, you might be in trouble. Okay. Thanks 1Z for uploading. Yeah, I'll take a look at it. So in this case, this is always like your initial. And then this is what we call like the common ratio. And if this is, yeah, this is kind of like the, I guess that the timing for it to happen. Because sometimes there can be numbers in front of this, and then, I don't know, it gets a little bit more complicated. But if there's just a T there. Yo, what's up, Zach? Shout out to Zach. Zach's a great guy. Shout out, Zach. Thanks for coming by, Zach. I saw your stream this morning. I was at the gym. I'm computer and software engineering, so I don't have Calc 3. Lucky you. Because, yeah, otherwise, like, Calc 3 can get, like, really, really messy. Okay, so explaining the ratio here, Blue, I would say that the common ratio is 0.85. So that what that means is the previous term, sorry, the next term divided by the previous term needs to be equal to that common ratio. So, for instance, like, a sub 2, or we could say this, a sub n plus 1 over a sub n needs to be equal to r. This is kind of the key thing in an exponential function. And all this means is this is like, I don't know, the current term. And then this is like the next term. So, I mean, doing this, let me find, where's my calculator? Where is my gold calculator? Can't have no gray one. Nope. Nope. No gray calculator today. All right. Yeah, if we were to do 5,100 divided by 6,000, I'm pretty sure that is 0.85. Yep. See how that one's 0.85? And then if you wanted to do 4,335 divided by 5,100, that's also 0.85. So I think that's a better explanation for reasoning. Maybe say that the common ratio is 0.85 and that each successive term is 85% of the previous term. That's what I would say. Okay. Girl drops a ball from a height of 10 feet. Each time the ball hits the ground, it bounces 2/3 of its previous height. The equation that represents the height of the ball after X bounces. That sounds like an actual explanation, yeah. Okay, I mean, yeah, I agree with this. Again, I would say that A equals A naught R to the T. A naught is equal to the initial, which in this case, yeah, is 10. That's fine. And then R is the amount... I would say, like, is the ratio of the... Keep up the stream, old man. Don't spend it all in one place. What? I can help you with redox. Yeah. Submit a screenshot right there. Actualofficehours.com. I love redox. So here I would say, like, the R is equal to 2/3. That makes sense. Right? And you could say every bounce, you know, makes the next height 2/3 of the previous. Yeah. That's what I would say. I think if you show this to your teacher, that's a pretty decent, like, explanation. And also, I mean, that's the whole... If you ever want to know, like, what your teacher's looking for, try to think about what the assignment is about. The assignment here is about exponential functions. And exponential functions are of this form. So, try to, like, connect to it all the time. Wow, that's actually really cool, Jay. Wait, how did you get effects on the chat, dude? What? How'd you get that? How'd you get effects? Message effects? That's really dope. H says I need help with calculus. Is that you, Odin Root H? Is that the infamous H? I don't know if it's a donation. Yeah, do you see that? That's pretty cool. See if you can do it, Zach. I don't know. Maybe you have to be a VIP or something. I'm only in Algebra 1, so he's going to think I use ChatGPT. No, just say, like, you asked your tutor. It's totally fine to have a tutor. But make sure you understand it, right? I think it's totally valid in Algebra 1 to understand this. Oh, it's like 20 bits? Oh, thank you, Shaq. 20 bits, okay. Okay, so let's look at this. Okay, great. So it says this many followers is decreasing at a rate of 5%. What is this? Okay, cool. So I would disagree, but what I would say here is that this is such that if it's 0.05 to the x, this means r is equal to 0.05. So next week is 5% of the previous week. Does that make sense? And if something is 5% of what it was before, that's a 95% drop. Right? So that's not a 5% drop. What you could say here is that in order for this to be correct would be 4898 times 0.95 to the x. This right here represents a 5% drop. Shaq has many different usernames, but thank you, Shaq. Yes. Yeah. Shaq's just edgy. It's okay. It's okay, Zach. Shaq, you're funny, dude. Okay, does that make sense? Blue? I'm not edgy. Yeah, you are. Edgelord. Okay. All right. Cool. Great. Good question. I'm going to hydrate. Thank you. So actually, I think I have an issue with that model. Ooh, you have an issue with it. Okay. Oh, is it the x minus 1, Zach? Is it because I didn't put like x minus 1? Uh-huh. Let's see what Zach says. I'm curious. JK friends, okay.
Oh, yeah.
No, I didn't know if I just did something wrong. You're good, Zach. Awesome. Okay, cool. Great. Good question there, Blue. Uh-oh, you didn't read the question? I don't read the question most of the times either. There have been so many times students like submit something for me to do, and I assume it's something I've already seen, and then I do like the completely wrong thing. And I'm like, oh no. Because it just reminds me of another type of question I've seen before. All right, good job, Blue. Yeah, then you saw an agree disagree. Yeah. It's like when you get IKEA furniture, dude. I never want to read the manual. I kind of like the challenge. They say also like building IKEA furniture together is one of the key relationship testers. If you want to see like if you can maintain a relationship with someone, like girlfriend, boyfriend, or whatever, see if you can survive putting together a piece of IKEA furniture. All right, let's see. Here's the queue. Thank you everyone who's submitting questions so far. We will get to them. Don't worry. This one's from Gladiator. First date, build IKEA furniture. You heard it here first. Yeah. Dude, these days, man, I don't know. Have you seen all these Instagram memes where they all talk about like things girls say are red flags for first dates? And it's like everything.
Huh?
It's like
if he breathes, it's a red flag.
Yeah, it's like no coffee date, no dinner date, no this, no this, no this, no this. I'm like, fine, fuck it. We're making IKEA furniture. Limited. Okay, here we go. All right. F of x is 16 minus x squared. G of x is sine of pi over 2x. Graph f divided by g on the same set of axes. Okay, cool. So let's make a graph of this, right? Yeah. So f over g of x. I don't know if this is probably like sacrilege to write it this way. This is the square root of 16 minus x squared all over the sine of pi over 2x. Good. And so, yeah, Jeff brings up a very good point here, which is that we should look at what the domain of this function is too. And I think Gladiator, what we were working with you yesterday was also involving like domains and stuff. So some key things that cause problems in the domain here would be this. Anytime you see square roots, that should tell you we have some restrictions. Mainly that whatever's inside the square root has to be greater than or equal to 0. So I'm going to take whatever's here. I'm going to say 16 minus x squared has to be greater than or equal to 0, right? So that's going to give me what? X squared has to be less than or equal to 16. Yeah, okay, good. Okay, so now squares and inequalities are kind of a mess. And I'm trying to think the best way to explain this. Because if I square root both sides right here, you might say, oh, x just has to be less than or equal to 4. And I mean, that's partially true, but then also you have to worry about the negatives. So, it's like x is less than or equal to plus or minus 4. But I'm trying to think of a good way to explain this. Maybe just drawing a number line would actually kind of make a little bit more sense. I don't know the explicit rules, the explicit math rule for how to take the square root with an inequality. But what you should see, right? Let's assume that we just looked at the positive root. We would say that x is less than or equal to 4, right? So that makes sense, right? Because once x becomes 4, you get 16 minus 16, which is 0. And if x becomes greater than 4, then you start taking square roots of negative numbers, which is bad. Right, the square root of x squared is absolute value of x. Okay, Perry, I like that actually. I really like that. Thank you. That's actually probably a better way to think about it. Yeah, let's do that. Okay, square root both sides. You get the absolute value of x is less than or equal to 4. It's just interesting, Perry, right? Because most of the times when teachers do this for a math exam, we don't do the square root thing, right? We square root, and then instantly we say x is equal to plus or minus 4. But then I think teachers only assume the positive root, right? I've gotten bamboozled on this before with elementary school stuff. Like, they'll ask the kids, what's the square root of 25? And I'm like, well, isn't it technically plus or minus 5? And they're like, no, it's just 5. Yeah. That's how you teach it? Thanks, Perry. Square root is a function. Yeah. Christian, if you want help with your homework, the website down there, actualofficehours.com, just submit a screenshot and I'll help you out with it. Yeah, you can say the square root of 25 is negative 5, but if you do that in whatever, primary school, whatever, they'll mark this wrong. No. Yeah. Right. It's technically, I think teachers assume the positive root. It's just what they assume. But I like Perry's way of doing it. That's actually kind of a cool thing. I'm going to use that more often, actually. Okay. So the square root of x squared is the same thing as absolute value of x. And then less than or equal to 4. So instead of doing the plus or minus 4, make this absolute value. This is great. I actually really like this. Yeah, I've also done the plus or minus, but you can't do the plus or minus when you have an inequality, is the issue. Yeah, that's a complex. Yes, on branch cuts. Yeah, exactly. So when this happens, open the gate. I like that. That's called open the gate. You come up with two different answers here, right? So whenever you have absolute values, you do one solution where you just get rid of the absolute value. So that would just be x is less than or equal to 4. And then you do another one where you can either make everything on the other side negative, or what I like to do is make everything inside the absolute value negative. So then this would be negative x is less than or equal to 4. And then when this happens, in order to get x by itself, you have to divide by -1. But when you divide by -1, you end up switching the sign of this. So this becomes x is greater than or equal to -4. So if you have something that's less than 4 but greater than or equal to -4, it sometimes helps to draw a number line for this, right? Let's say this is 0. Let's say this is -4. Let's say this is +4, all right? Inequalities are pretty easy. Just as long as your variable is on the left and the number's on the right, this points where the arrow goes. So equal to means a solid circle, and then to the left, right, means it's going to go that way. This one is x is greater than -4, and it's because it's an equals, greater than or equals to, you can put a solid line, and then we're going to put the arrow to the right. Okay, and so then the overlap space is here. Okay. So that tells me right away that x is defined between -4 and +4. Okay, which they kind of did here. Well, actually, they drew 6 here. Can I stay on your couch for like a week? I'm down on my luck. I mean, sure. Do you live in Los Angeles? Why do you switch the sign? Okay. Nards, good question. Anytime you divide an inequality expression by a negative number, or you multiply by a negative number, you have to switch the signs. It's just a rule. Why you have to do it? I don't know. There's probably a proof somewhere. Nikki says I'm outside right now. No, it's okay, Shantrix. You had a good question. Why? I don't know why, actually. Jeff says -5 is less than -4, but if you multiply by -1, 5 is greater than 4. You can tell me, Nards? Okay, well, tell me. Thanks for making my night, yeah. Also, yeah. Oh, flip over the origin. Okay, cool. Yeah, so, the other thing here, Gladiator, right, is that the denominator cannot equal 0. Right? This cannot equal 0. So we got to think about where sine is equal to 0. And that happens whenever this is 0, pi, 2 pi, 3 pi, like basically any multiple of pi. Right? Because on the unit circle, sine is the opposite over the hypotenuse. Right? So the opposite is 0 at 0. It's also 0 at pi, and then at 2 pi, and then at 3 pi, and then 4 pi, like as you go around, right? So that puts some restrictions on x. Oh, and also for the negatives as well, right? Interesting. Okay. How do you get better at math? Practice. So right away, right, this course, so you can say right here that, like, if you want to put this as a math expression, you say that pi over 2x cannot equal 0. Cannot equal, n pi. Okay? Where n is any number. You can say, like, n is equal to, like, -1, right, -2, -1, 0, comma 1, comma 2, comma ... So it is going to be an ugly function. I agree. You're going to divide by pi, right? And so you're going to say that x cannot equal 2n. So this is very cool. This just tells me that x cannot be even, right? X cannot be an even number, right? Because if n is 0, x can't be equal to 0. If n is 1, it can't be equal to 2. If it's -1, it can't be equal to -2. And so forth and so forth. Does that make sense, Gladiator, so far? Right? X cannot be even. Yeah, Dojo has... Yeah, I agree with that, Dojo, too. Be better at math. Don't fear being wrong. Yeah. And honestly, that's a lot of what I try to do on this live stream. Is to normalize that it's like, it's okay to make mistakes. It's okay to be wrong. I'm wrong all the time. No. But we learn from it. How often do I stream? I stream 4 times a week. If you want to figure out when we stream, the same website that people are using to submit their questions, there's a schedule here, a little calendar. If you click on the calendar, this has a big overview of all the times that we stream, and also we have a lot of other awesome friends who stream math and science stuff, such as Zach. He's in our chat, either 2i Pie. So he has, for instance, a stream tomorrow. He's gonna do math through tasks. This is cool. Is this like an applied math stream? I don't think I've been to one of these streams yet, Zach, for you. And then he's also do some DiffyQ stuff, but yeah, we stream tomorrow as well, a little bit later, and then we'll stream again on Thursday, and then we'll stream again on the next Sunday. So go check it out. All right, let me get back to this. So Gladiator Rios, Gladiator understands. So it just can't be even, right? So we already have this restriction that it can't be greater than, it can't be more to the left of -4, and it can't be more to the right of 4. And also it can't equal this, can't equal this, and it can't equal this, and it can't equal this. Okay, cool. All right. So to graph, I think at this point you just plug in points. Literally, right? I think the only way to do this is just plug in points. I fake making mistakes as a learning aid? No. I wish. Dojo says, I think the reason I'm good at math is I delight in discovering that's what I thought was going to happen and was not going to happen. Thank you. Yeah, no, that's fun. Blue says, if you really want to get better at math, go to Khan Academy, use ChatGPT, create practice problems. Yeah. I'm going to develop, because I know a lot of students in our Discord were well, at least a couple of them, they use AI extensively, not to cheat, but to create practice tests, because for whatever reason, their teachers are too lazy to create like practice test things for them. Huh? So, but they run out of credits, is what they say. Like they obviously, like, students don't really have money; they don't have credit cards, but they run out of credits to upload their quizzes and tests to make practice tests out of. So I am gonna work on, that's a thing for me this month maybe. Because we have a pretty big budget for ChatGPT credits that is just donated to us. So I'm gonna work on creating a bot for you guys that you can use in our Discord to just create practice questions without running out of whatever the free things they give you. It's next on my list of things to vibe code. Okay, let's just look at some points though, right? Let's look at X and Y points. 0 is always a great thing to do, right? Nards is right. It could be good to graph these separately. I just think it might be a little involved to do that. I agree that the square root of 16 minus x squared, that's not too hard, right? That looks something like this. But then sine of like pi over 2 over x. What is that? It's just like an extended sine function, right? It's just kind of a mess to line up the angles here. The top is just a circle. Oh, actually, I do have that wrong. You're right. You're right. 16 minus x squared is this. Yeah, you're right. You're right. You're right. It's this. Sorry, my bad. You're right. I thought it was just the square root of x squared. Yeah. Or, whatever. Yeah, okay, got it. Yeah, this one is just, it's just half a this is a semicircle. This is a sine wave that's extended out. But then lining up the points would be kind of a pain. But maybe you're right, actually. Okay. Actually, I kind of like Nards' idea. Let's just do it. Because, yeah, right away... Oh, this function can't equal 0. So this is, like, undefined. Yeah, increments to 1. Yeah, let's do it. Let's do it. Okay, fine. What's up, X-Man?
Good job.
Yes, exactly. Most of the points don't work, Bream. Yeah, you're right. Yeah, because, yeah, I already can't do 4, 2, 0, 2, 4. So maybe... yeah. And we'll see why that is. Okay, so 16 minus x squared. Let's just graph that one first. I'm going to make that one like a green function, right? So I know when x is equal to -4, you get 16 minus -4 squared. But -4 squared is 16. 16 minus 16 is 0. So this is going to be 0. So let's do this. So this will be 0 here. And then when it's positive 4, it'll also be 0. And then when x is equal to 0, this will be the square root of 16, which will be 4. Right, and so this just ends up being a semicircle. Yeah. You should also recognize this. This is the equation of the top half of a circle. All right, sine of pi over 2x. So sine of x looks like this, but the pi over 2 like extends it out a little bit. So this is where it does help to know your trig functions and how to graph them, or at least what the key points of them are. So for instance, in sine of x, this is 0. This is pi. This is negative pi. Right? And then this is pi over 2. And then this is negative pi over 2. Just useful to know. So, oh, and then, but we're going to go all the way up to 2 pi. Okay, so you have to do this, actually. Yeah, so let's do another one out here. So then this would be 2 pi. And this would be negative 2 pi. And then what? That would be negative 3 pi over 2. But many real numbers. Yeah, many real numbers indeed. Okay. So when x equals 0, you get the sine of 0. The sine of 0 is 0. And that's the center thing here. When x equals 1, that means we're doing sine of pi over 2. Did I do something wrong here? This is just regular sine of x. Yeah. Yeah, okay, so I'm going to draw it this way. Yeah, this is regular sine of x, and then I'm going to show what it would be for sine of pi over 2x. Let me do a different color for it, actually. Right, like that. No, you're good. No, yeah, thanks for keep me on. Keep me honest. So when x equals to 1, it's pi over 2, and so that's going to be at 1. So that's going to be here, and then it's going to be here, and that's going to be here, and that's going to be here. See how this part right here looks like this part? And then that means for this is going to go like this, 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 this. Cool. So then if you do this divided by this, you can see where there are issues. Because when you divide by the sine, which is the blue function, you're going to end up having asymptotes whenever that blue function is equal to 0. Because you're dividing by 0. So yeah, these are going to cause like issues. Exactly. Yeah. Yeah, you can see how it's a horizontal shift. You're really right, Nards. That's correct. But it turns out you don't. Exactly, Jeff. Yeah. You're such a good dude. Thank you, GMAT Prep. I remember seeing you earlier in the year, or last year, I guess. How's your TikTok going? Okay. So, ooh. So I guess what I'm seeing is that, you know, between 0 and 2, the function is like kind of decreasing a little bit on the numerator, but the denominator is varying pretty wildly, right? So we're going from dividing by like 0, which is like positive infinity. So that's like something up here. And then we're going to divide by the biggest number, and then we're going to divide again by infinity again. Divide by 0 to get infinity again. So I think it's going to end up looking something like this, right? Kind of. And then here we're dividing by negative numbers, so it's going to look something like this. I think it kind of looks something like this. It's just weird. It's a very weird function. I don't know if a student would get this right off the bat. Gladiator, for instance. Yeah. You have to understand that, like, you know, between here and here, whatever the numerator is, the green part is basically kind of constant. Because you're going from, I don't know, 4 to... What is it? 4 to 2 squared root of 2? 4 to like 2.8? Your teacher says something like, yeah, this seems intense for a student. Nard says this is intense. Yeah, Leos, you're in like high school, right? Or is this middle school? What level is this? It's a little intense for... I think what you can at least do, you should get these points. Get where it is in between. Get -3. Middle school would be wild. Oh, it's grade 12. So it is high school. It's end of high school, senior high school. -3, -1, and then I would get +1, and then I would get +3. And just see what you have, right? So, if you were to plug in -3, you get 16 minus 9, which is 7. And then, square root of -3 pi over 2 is positive, I guess. Yeah, it's positive. It's +1. You just try to table of values. I agree. So, yeah, whatever. This is like square root of 7, negative square root of 7, right? Square root of 7, negative square root of 7. So you could get these at least pretty easily. These points. But then determining the asymptotic behavior, you have to kind of understand what sign is doing. What the bottom is doing in between there. Right? You have to, like, these definitely approach asymptotes. And then I guess because you know this is here, that it's probably doing this. It's not doing this, right? It's because it's not crossing. Right? There's nowhere. This has no x intercepts, because there's nowhere that the numerator will be equal to 0, unless it's at 4. But it can't be at 4 anyways, because this breaks it. Yeah, so just table of values, and then I mean the typical things that you do when you're graphing polynomials is figure out domain, figure out range. The range is infinity, right? Because you're going to divide by something very, very small, which becomes something very, very big. And then also horizontal asymptotes. So horizontally, this top part is basically like, it's basically just x. And then this is between -1 and 1. So the horizontal asymptote, there is none, right? There's no horizontal asymptote, I guess. There's a gap in the range. Yeah, exactly. It's kind of annoying, honestly. Yeah, this is a tricky one. This is tricky. Tricky to solve. But, hopefully, I think this part's probably the most crucial thing for your teacher, showing where the domain is, and then showing, what values of x you can't have. I don't think this is calculus. This is just called functions. It's Canada. It's Canadian math. They do funny math up there.
Surprise, motherfucker.
Okay. Does that help you out, Gladiator, at least? Yeah, this one had you thinking. Yeah, cool. Very good. Awesome. Great. So yeah, I agree with what Nard said. To do it properly, it's cool to graph out each function individually, and then see like what happens when one divides by the other one. But might be a little tricky. You can also, I mean, just for time's sake, just find the domain and then plug in some points on a table. Cool, good question. Let's see what's next on the queue. Habitual. Use the double angle identity. Ooh, nice. These are fun. Oh, you added what you did? Oh, on the queue. Let me see. Yeah, okay. Yeah, square root of 7. Right, okay, this is smart. Yeah, this is a good way to do it. Yeah. Yeah, you're basically just plugging in values and then showing that what divided by what, yeah. Cool. Yeah, this is a good way to do it as well. I agree. Okay. Use the double angle identity to find the exact value of cosine of 450 degrees. Thanks for the rose, G-Matt. The double is that like cosine of 2 theta is equal to sine theta cosine theta? Is that right? Oh, it's 1 minus. Yeah, okay, this is it. Actually, there's actually a couple of them, actually. That's the sine one. Thank you. Thanks, Nards. Yeah, I always forget, like, which one that is. There we go. There's a couple of them. And then we're going to need the half angle identity. Okay, fine. Okay, 450. Okay. So, I would say cosine of 450 degrees. You want to write this as 2 times something that's easy to do. Which, yeah. So, this is the same thing as the cosine of 2 times 225. Right? And then, which one do we think is going to be easier? I guess it doesn't really matter, does it? Because they're going to be the same, actually. Okay, so let's use this one. It's kind of easy, right? You want to use the first one? All right, we can use the first one too. Let's do it. Okay, so in this case, this right here is theta, right? Because you have 2 theta, and so this is going to be equal to the cosine squared of 225 times the sine squared of 225 degrees. Yeah, let me don't forget the degrees. Okay. This is just square root of 2 over 2, but let me show you why it is. Well, it's either positive or negative, but then we're squaring it anyways. Why can't you just put cosine of 450 in the calculator? Oh man, it's a good troll Shantrix. It's because they want you to use the double angle identity. All right, 225 degrees. Let's see where that is, right? So this right here is 0, 90, 180, 225, right? That's how I like to draw things. I'm gonna say that, cool. This whole thing is 225 degrees, which means that this angle right here, which I call like the principal angle, I guess, or reference angle maybe, this is equal to 45 degrees, right? And then based on that, you can then make a triangle, right? You can make a nice little right triangle from this. Where if this is 45 degrees, what you learn about the 45, 45, 90 is the hypotenuse is always 1, and then this is going to be negative square root of 2 over 2, and then this is going to be negative square root of 2 over 2. Where, right, this is the opposite, and then this is the adjacent. Now here's the cool thing, right? So cosine is adjacent over hypotenuse, right? Which would be, this would be negative square root of 2 over 2 for just cosine, but then you're squaring it. So it's that squared. And then the sine would again be opposite over hypotenuse. It's the same negative square root of 2 over 2, but it's squared. So then what you get here is you get 2 over 4 times 2/4. So you get a quarter? Wait, 450 degrees equals 90 degrees? Jeff, wait, what? Oh, it is, yeah. It's 360. Yeah, you're right. Wait. So wait. Yeah, the answer should be 0. Wait, why are we not getting 0? Yo, what? Wait, how do we not get 0? What did I fuck up?
Surprise, motherfucker.
I done messed up, AA Ron, dude. Wait, what? Where did I mess up? What? Yeah, okay, I agree. Yeah, Nards is like, Yeah, do you understand this, Nards? Like, does the double angle identity not work for certain things? Okay. Because, right. Where's my fucking emotes? Okay. Right, going around, that would be 360 degrees, right? And then if we went an additional 90. Oh, the green identity is wrong. Oh, Jesus.
No.
What's up, Narosky? What's going on, dog? How's it going, dude?
Yo, I just woke up right now.
Oh, good morning.
Yeah.
I was gonna announce
Actually,
your
right?
What's up?
Actually, good evening for you, right?
It is the evening for me. It's 6:16 right now. Dun, 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 dun. Wait, is this identity just wrong?
This identity is wrong because it should be cosine squared minus sine squared.
Oh.
They're forgetting a minus at the middle.
Dang, dude, what?
See, that's correct. How they have it here.
Oh, wow. We got told dude, Google Images gave us the wrong identity, dude. No. Wow, that's fucked up.
This is where you should memorize some formulas.
Yeah, you know, I'd memorized the sine one, Narosky, but I hadn't memorized the cosine one. I think that was my issue.
Yeah, fair enough. Sure.
No, Nard, it's not your fault. It's whoever this fucking dumb bag on Medium. Like, here, we should. Satoshi Higashino wrote down the wrong identity in his Medium article. Dude, someone needs to shame this person in the comments, please. Yeah, there you go. Your formula wrong, bro. Yo, fix your formula, man. Yeah, shame, dude. Shame on this person, dude. Wow, look at that. Fix your formula. Fix your formula, dude. The problem with that, man, is, oh man. Yeah. That's hilarious that that's like one of the first things in Google Images. Shame on that guy. Okay, all right. So let's just do this real quick. My bad. Okay, let's just do, I'm gonna just do 1 minus 2 sine squared theta. I'm just gonna do this one. Or we could have done this one, actually. Sure. Cosine squared of 225 minus sine squared 225. And then it's that minus that, right? Which is just equal to 0. And we're done! Yeah, good job. Big L to Satoshi, dude. Wow. We should D-rank that guy on Google.
Well done.
Nice. Good question, Habitual. Alright, let's see. Habitual, good. Hope that made some sense. Oh, you need the half angle identity. Sorry, we didn't do the half angle one. Let me do that one real quick for you as well. Sorry, Habitual. Yeah, let me do the next one. Forgot about this one. This one's not bad. You got the double angle. Oh, do you not need help with the half angle one? Oh, okay, cool. Good. All right, cool. All good. Cool, cool. All right. There we go. Electrons. Let's do it. We're doing some physics. Thanks, Nards. Appreciate it, dude. Thanks for the help and the support during the stream. Crap, more physics. We love physics. Okay. Actually, this is chemistry, I think, maybe. Or no, it's not. Wait, it is kind of chemistry. Ish. GZ Dizzy, yeah, Narowski's asking you, GZ Dizzy, if you know what a PID is. Because I think, let's see, what is your question? This is your question? Narowski might work on this one while I do the other ones, because I actually don't even know what the fuck this means, but Narowski does. Narowski's a very smart, like, I would say, like, more abstract math person than I am. Okay. Yeah, it's a mix of chem and physics. I agree. Okay. First four energy levels are that after collision, the atom is in the excited state and the electron is scattered. The kinetic energy of the scattered electron would be... Okay, interesting. So, I think the electron is going to scatter up to as high of an energy level as it can. Right? So, you have an incoming electron here that has a kinetic energy equal to 7.74 electron volts. And then it's going to hit an atom which has a variety of different, we'd say, like, energy states, energy levels, right? There's a bunch of these. Maybe, yeah, right? Okay, and then, is E1 the ground state? I assume that's the ground state, right? Not n equals 0, right? Yeah, okay, thanks, Nell, yeah. So this is going to be at negative 8.57 EV. And this is kind of like potential energy, right? I need to, like, zoom in a little bit. Okay, so this electron comes in, it smacks this thing, and then this thing is going to, like, go up. And I think it's going to go up as much, the most that it could go up would be 7.74 EVs. So let's see what that would be, right? So if we had negative 8.57, I bet your kids definitely go or will go to you for homework help. They definitely do, Onesie. Plus 7.74 EVs. What does that get you up to? I need a calculator because my head's not in the game right now. Where is it? Okay, negative 8.57 plus 7.74. So the maximum amount of energy it could be transferred to is to negative 0.83. So that's the maximum amount that this thing could jump up to. But so it's not going to get to E4, right? It could get to E3, right? In order for it to get to E4, it would need more kinetic energy coming in to get up to negative 0.54. So, yeah. 1, 2. This will get up to E3. I think. So we put, like, a little arrow. Or here, we can... Yeah. So it's going to travel that way, and then this one is going to have negative 0.95 EV. Okay. Right, and so if it gets to 0.95, let's think about how much kinetic energy had to be absorbed then, right? So negative 8.57 plus 0.95. You could also just do final minus initial, right? You can do this. Negative point. So delta E. E final minus E initial. Which equals negative 0.95 minus 8.57. Is that right? Yeah. Negative 0.95 plus 8.57. That gets me 7.62 EVs. Okay, so that's how many EVs are needed to jump from n equals 1 to n equals 3. And you had 7.74 EVs of kinetic energy. So that leftover energy is going to still remain in the incoming electron. And so leftover is equal to 7.74 minus 7.62, which is equal to 0.12 EVs. And so, yes, I agree with answer choice D here. That's the kinetic energy of the scattered electron. Interesting. Why do you think it was 0.83? Oh, you just guessed? Okay. All good.
Good job.
Totally cool, Nelu. Yeah. You know how to do it on a test. All right. Yeah. Well, if you understand it now, yeah. So, change in energy. These are all like potential energies. It's weird that they're negative, I guess, but you should see that things are becoming less negative as they go up, right? This is negative 8, and then this is like negative 0.95, right? It's similar to how like gravitational potential energy works, right? So the higher something gets, you know that like potential energy is equal to like mgh, right? So as your height gets higher, your energy gets higher. It's kind of the same with electrons getting further away from the atom. The height is just like opposing the Coulomb force. The Coulomb force wants to keep these things together because the nucleus here is positive, and the positive wants to like pull in the negative things. And so as you take them further and further away, you have to put in more energy to do that. To bring something further away requires more energy. Yeah. Cool. So, yeah. It's... And the reason why the potentials are negative is because these things have negative charges. Yeah. So, yeah, think about it as, like... It's the same as gravity with potential energy, except instead of, like, the gravitational force pulling you down, it's the Coulomb force trying to pull these things in. What's interesting is it's non-linear, though. So, with gravity... Every additional meter that you pull something away from the Earth, at least on the Earth's surface, is technically the same amount of energy. So for me to take something from 1 meter to 2 meters is the same amount of work or the same amount of energy to take something from 2 meters to 3 meters. But in the case of here, right, look, going from E1 to E2, this was a jump of like 6 EVs. Then this is a jump of like 1 EV, and then this is like a jump of like 0.5 EVs. Do you see how the jumps are like not the same? And this is because the force is equal to K Q1 Q2 over R squared. The force is proportional to the square of the distance. Technically, yes. I know that gravitational force is also proportional to the square of the distance, but for the purpose of things on Earth, it's linear because the R squareds are. It's negligible, I guess is what I would say. Yeah. So this is like Coulomb, and then this is gravity. Gravity is just F equals mg. Actually, the interesting thing here is, right, yeah, okay, so energy, what I should be writing here, UE is equal to KQ over R. Here, UE is equal to mgh. Yeah, that's what I meant to say. Okay, whatever, cool. Great. All right, yeah, cool stuff. Good question, Nilu. Habitual. Or not habitual, sorry. Nello. Habitual was the last question. Nello. Nice. All right. It's kind of fun. They're doing chemistry and physics. They are very related to each other. In the hierarchy of sciences, chemistry and physics are best neighbors. You guys ever seen this, like, hierarchy of science? Everyone loves this. I always love doing this. Dude, why put social sciences at the top? It's so wrong. Yeah, this is the key thing you want to see. Yeah. So generality, complexity. Yeah. So interestingly, put astronomy as a separate thing. Okay. But physics and chemistry are best friends. Sometimes in school they say this from like hardest to easiest, right? Math is probably one of the hardest things. At least in my mind. I think getting a PhD in math would be impossible.
Surprise, motherfucker.
But as you go down, it gets easier and easier. Oh, atomic physics, yeah. Yeah. Factoid, it takes more energy to send garbage to the sun than to send it out to the solar system due to the Earth's kinetic energy. I didn't know that. That's really cool. Oh, it's 7-6 for the Steelers. Who's up? Steelers or the sorry, who's playing? It's Steelers and and the Texans, right? Because today's Monday. Who's up? Texans or Steelers? Texas is up. Oh, I grew up in Houston, so I am kind of biased towards the Texans, but the Steelers are. They have a coach, I think, that's been there for like 20 years or something. All right, Dane, let's do this. Oh dear. I might not be able to do this, but we'll try it. Use induction. Induction. I used to hate induction. I think I still kind of hate induction, but I'm getting better at it. Suppose B is the matrix obtained by A by exchanging row I of row J. Row I and row J of A. Prove that the determinant of B is equal to the negative determinant of A. Oh. I mean, induction is usually you show a base case, and then you show for like the nth plus 1 case that it holds, and then you can make a generality about it, right? How do you do induction with matrices?
So what this is saying? Sorry if I'm butting in.
No. You're allowed to.
That,
please butt in, Neurosky, please.
This is a fact in linear algebra that if you change 2 rows or 2 columns, the determinant does not remain constant. It actually changes by a factor of -1.
Okay.
And how you'd go to prove this is, do you know the general formula for the determinant?
I know it for I know it for specific like n by n's. I know what it is for a 2 by 2 and a 3 by 3.
Yeah, but what I'm asking is if you know like the formal definition of a determinant.
I don't.
So it would be it's more helpful if you look it up then, because it's pretty long.
Okay, let's look it up.
Instead of me telling it to you.
Yes, no, you're totally good. Thank you, Marcy. Formal definition of determinant of a matrix. Let's see what we get. Is this the one I want, you think?
I think it's nicer in the second image.
Yeah, this image. This image is a little bit nicer. Okay, let's do this.
Yeah. That's actually only for 2, but we'll work it out from there. Yeah.
Okay.
Okay. So it's the sum of all permutations, right? So it's the pi there is a permutation.
Oh, interesting. I didn't know that. Okay, permutations.
Yeah. So all permutations in Sn, it's the sum of the sign of those permutations multiplied by the product of all the elements of the matrix A, with the indices k being like the k we're at right now, and the other in this index being the permutation value at that point, right? So if we'd have like the permutation 1, 3, 2, we would have a of 1 and 1, a of 1 and 3, and a of 1 and 2.
And then, okay. And then permutations of P. Sorry, what are the permutations of P?
I think they use P here as the set of permutations of like 2. Like there's permutations of like, do you know symmetric groups?
I don't know symmetric groups. Yeah, what is that?
So it's the set of all functions that map 1, 2, and so on up to n into itself.
Okay.
Right. So it's only positive integers mapping to themselves. For example, S index 3. So S of 3 would be the set of permutations that contain 1, 2, and 3. Right. So it would be 1, 2, 3, 1, 3, 2, 2, 3, 2, 1, 3.
Oh, okay.
Right? So
Gotcha.
It's just a set of permutations of these given.
Oh, I see.
Yeah. So if we have S index n, that would just be the permutations of n positive integers like 1 through n. Right. So this is what it's saying basically. It's if you would formally write the. Actually, this is a good example because it's showing us how it computes
for a 2 by 2, right?
Right.
Yes, this is showing how it works for a 2 by 2, right? I guess, yeah.
Yeah.
So it says permutation 1, permutation 2, and that's because if it's a 2 by 2, right? Then I only have like 1, comma 2.
Right, sorry, 2, comma 1.
1, comma 2, and 2, comma 1. Okay.
Yeah.
So I do the sign of permutation. I don't know what the sign of permutation 1 is. Is that positive, I guess? What does the sign of the permutation mean?
So the sign of a permutation is 1.
Is this the plus minus plus minus?
Yeah, it would be plus 1 if the permutation is even and minus 1 if it's odd. Right?
Oh, okay.
How many, like, you look at how many inversions there are in a permutation. Do you know what an inversion means?
No, I don't. No, this is cool.
So an inversion is, you see how the second one is practically the inverse of the first?
Yes. Okay, cool. This is the inverse of this one, yep.
Yeah. So that would be an inversion, right? If we'd have, like, instead of just 2 numbers, we'd have like 5. We would have like the first one, let's say it was 1, 2, 3 up to 5, right? It's the identity permutation, we call it.
1, 2, 3, 4, 5. Okay, sure. Then the inversion for that would be 5, 4, 3, 2, 1.
That would be the inverse permutation, so it's the exact opposite. But an inversion is just 2 of them swapped, right? So let's say we just swapped 1 and 2, and that would be an inversion.
So this is an inversion of this one? 2, 1, 3, 4, 5 is an inversion of 1, 2, 3, 4, 5?
Yeah, so we'd say like we denote it instead of just writing it all out. We just say 1, 2, like in parentheses 1, 2 is an inversion.
Okay,
that's how you denote it.
Someone in the chat here, because I think this is their question. This is Dane's question. He says, "I was taught that the determinant is equal to the sum of the A LJ times CLJ, where A is the entry of some matrix and C is the cofactor of matrix A. I'm supposed to use this definition throughout my homework when proving identities of determinants."
Oh, I see. So they want to do it with cofactors.
I don't have no fucking clue what a cofactor is, but Narowski, do you know what a cofactor is?
Yeah, of course. So the cofactor of a matrix is let's say you would eliminate a row and a column to compute the determinant. You know how you do that?
Yeah, I know when. Oh, okay, when we're doing like a 3 by 3, for instance.
Yeah, for example, let's say we'd have a 3 by 3. If you have
I do this, right? And then you're saying this is the cofactor, and then I do this one.
Yeah.
Okay.
So Yeah. The cofactor is the number and the sign of that number. So if it was in the first position, it would be
It's plus
positive,
minus
'cause it's-
plus minus
yeah.
plus minus, right? Yeah.
Yeah. For that, we'd say it's -1 to the power of the sum of its indices. So in this case, it would be -1 to the power of 1 plus 1.
-1 to the I plus j. Oh, okay, that's cool.
Yeah.
Okay. Very cool, actually.
Yeah.
Okay.
And this is the cofactor, so it's 1 times its sign.
So Hallman says that the formula for the determinant of a matrix in n dimensions does use a cofactor matrix. Wow. Oh, we're getting to some advanced stuff. Okay.
Yeah, this is a bit advanced, yeah.
Go on, Narowski. Well, you let me know if you can't do it anymore. But if you can, like,
No,
I would love to keep learning.
I think I can do this. It's
Okay.
not difficult, like, explaining stuff, but I think I like this. I like doing this.
Okay, so do we need any of this? Can I get rid of this? Do we need this?
We can keep it, yeah. Why not?
Alright, let's just-
Maybe if we can, yeah. If we can do it, otherwise maybe. Yeah. So what I understand by what I was just told,
Yeah.
is right.
I see, because usually what you do, right, when you're taking the determinant of a 3x3, this is the cofactor, right, and then I'm multiplying it by the determinant of this, and then I'm taking this time.
That would be called the minor, the minor of the cofactor.
The minor of the cofactor. Okay, I think I understand that. Sure. Okay.
Okay, so that's basically what that formula was doing, like what I just kind of gave to you, right?
This thing right here.
Yeah, that's kind of what it was doing. But what they're asking us is to expand it, right? So it's not asking us just to compute it along the whole determinant. Like it's asking to expand along row I. Like,
okay.
So induction on this would be. We would take a base, so when we'd have n equals 1, it's asking us to prove. So first off, we take n equals 1.
Okay.
As the
So-
base case.
Alright, so base
matrix,
case.
The matrix, that's, yeah.
All right, because how I understand induction is I do a base case, right, and then I show for n plus 1 that it also works, and then I can imply that it works for everything, right? So the base case is
Exactly.
n equals 1, but
Yeah,
that's
and
that's just a number.
What does n equals 1 mean? Yeah, that's exactly
Just a fucking number, right?
So
Yeah.
swapping it is, it's
trivial.
vacuous, literally, like, yeah. Right, so
Okay.
yeah.
Yeah. Okay. But
Now, I don't think...
wait, how do I show that
we can do...
wait, the determinant of this is equal to the negative determinant of what was it saying? Exchanging the row I and row j. But this doesn't have an I and a j. This only has row I. I think we need to start with an n equals 2, right?
Yeah, I think we'd prove it, like, for n equals 2 as well.
Yeah, let's prove it for n equals 2. Einstein notation. I don't want to do Einstein notation. What? I don't want to get that complicated. Levi-Civita.
Yeah,
I've heard of Levi-Civita, and I've done it at some point. At some point during my graduate career in physics, I had to do it, but I don't remember anymore. So let's do the base case n equals 2, maybe? Yeah?
Yeah, so let's just do A, B, C, D, right?
Yeah, let's do A, B, C, D. I like this. I like this notation. Okay. And so the determinant of this would be
let's
what?
denote it as AD minus BC. Let's denote it as A, the matrix A. So it's easier.
Okay, let's say it's matrix A. Cool, great. Matrix A.
Yeah, so the determinant of A is AD minus BC.
Correct.
So and then B would be, let's swap row 1 and row 2, right? For example.
Okay, sure. All right, yeah. Those are only two rows we can't, right? All right, so let's like B.
Oh, it's asking only for rows, right? It's not columns.
Sure. Yeah. Well, I mean, this is
Yeah.
row 1, right? This is row 2. So.
Yeah.
Okay, so sure. Then this is CD, AB.
Yeah.
And yeah, cool. The determinant of this is going to be negative, I guess, right? Yeah. Because this is going to be BC minus AD. Which, yes,
Yeah,
I
so
agree,
it's-
is the negative of that. Yeah. Okay, sure.
This is trivial. Yeah.
This is cool. Okay, cool. So yeah, determinant of A equals negative determinant of B. Awesome. Now, how do we do the induction step to like show the plus one?
So the thing here is like, since we want to use the cofactor formula, the cofactor formula actually requires that we know everything about the other parts of the matrix, right? So we cannot just say anything about the cofactor of a 5x5 matrix if we don't know anything about the 4x4 minor or the 3x3 minor or the 2x2 minor, right?
Gotcha.
So that's why I think that the induction step should contain all n-1 by n-1 matrices, right? So we suppose that this holds for every matrix up to n.
Okay. To size n.
So it's
right.
it's complete induction. If you'd heard that term before.
I have not. Okay. So suppose this.
The statement, it holds for all n-1 by n-1 matrices.
n-1 by n-1 is what you're saying?
Yeah.
Okay.
And we're gonna just prove it for n. Yeah, we want to
Oh,
prove
I
it
see. Because what you're gonna say is that eventually I'm always gonna get down to a 2x2.
Yeah. Yeah, kind of.
Okay. Mathematic Fanatic
I
says
think
weak induction is surely sufficient because you only need one size down in the formula. So wait, are you saying that we could just show for a 3x3 it does this, and then for a 2x2 it does this, and then just be okay? Let's go with, let's keep going, Narowski. What do you want to do? Okay.
I'm currently thinking about like.
I like the idea. I like that instead of going up. Well, we are going up, right? So we're going from looking at a 2x2 to looking at, hey, what's the determinant of a 3x3? And what we're going to show is that, the determinant of a 3x3 is the same thing as eventually getting down to the determinant of 2x2s. And then we're going to show that, for instance, like a 5 goes to a 4 to a 3 to a 2. Then a 6, 5, 4, 3, 2, 1 or something, yeah.
Yeah, I'm thinking like we could just do like weak induction, like how the mathematic fanatic is suggesting, but then we would I think we'd have to like justify that the result happens repeatedly, right, for each swap.
Okay. I had no clue there were two different types of inductions. I didn't know there was weak or strong. Canned Peaches says it's okay to use weak. So I didn't even know there was a fucking difference. Like, you guys are teaching me stuff today. This is cool. Zach seems to agree. Zach says weak is okay as well. Is it easier for you to explain weak, Narowski, or is it easier for you to explain strong?
I think I can do weak.
All right, let's do weak.
Well.
It's okay.
Yeah.
We got our strength in this morning. Let's do some weak induction. All right.
Okay. So, right. The determinant of A would just be like its cofactor, right?
Okay.
Times the minor that remains after eliminating the rows.
Determinant of A is equal to like a cofactor.
It's the sum. So it's because if you expand it, it's gonna be
It's the sum.
You're gonna have to It's the sum from k equals 1 to n.
Sure.
How do you want to denote the cofactor?
Well, how's he denoting it? He says A1j times C1j, where A is an entry of some matrix and C is the cofactor.
Okay, yeah, fair enough. So in this case, it's the row 1. So we want to do it for all rows. So it's actually for an arbitrary row. So let's just say a RK from so row R and like column K.
Okay. Row R, column K. Okay, cool. And then these are the columns. Great. Okay. And so then the cofactor is
ARK in this case.
ARK? Okay.
Yeah.
Like that?
Yeah, and the minor C, right? So he wants to denote it as C.
Uh-huh.
RK.
CRK. Oh, I see.
Yeah.
And is this... Sorry, and then... Okay. But this is usually 0, right? Or 1, I guess? Isn't the first row usually where the cofactor is?
No, you can get it actually anywhere. So that's why it's important to generalize in
Oh,
a
I
proof,
see.
right?
So the trick when I do this, that's just a convenient trick. You're saying I could also do it this way?
You can literally do it on the 5, right? So it's gonna be the minor 1, 3, 7, 4, and the cofactor 5, right?
Yes, Red Roach, I do have a PhD. Not in math. I have a PhD in physics. But yeah. Okay. All right. Okay, cool. That's cool. So I guess in school, they only teach you to use the top row as the cofactor. But you're saying you can use it anywhere. That's actually really cool.
And then I suppose let's have a matrix, another matrix. How do you want to denote it? Denoting it as C, okay? No, we already have B.
Oh, we already have B. Okay. Matrix C. You want to talk about matrix C then?
Yeah, sure.
Yeah. And we're going to talk about the determinant matrix C?
Yeah, so let the matrix C be the matrix by swapping just 2 adjacent rows, right? So R and R plus 1.
So swapping R and R plus 1. Okay, sure.
Yeah, so this is actually going to be equal to the sum of the cofactor at R plus 1 and the minor at R.
It's okay.
K.
R plus 1K. Okay, sure. And then
And it's gonna be the same minor.
And then it's the same minor. Okay.
Let's say it's C prime because it's different than
because
the
it is going to
C
be a different
before.
minor. Yeah, right. It's going to be a different minor.
It's going to be a different minor, but it's going to be at the same position.
Okay, cool. That's fine.
Right. Okay, so I think we'd have to analyze, right, just the minors. Like what's different between the 2 minors?
If I were to do the 3x3, you think, just to see what the different minors would be?
I'm thinking, like we want to show that, for example, the minor in A is gonna be the negative of the minor in C. That's what I'm thinking. We'd have to
So let's say this is matrix A, right? And then some matrix C would be, let's swap the first 2 rows, right? So D, E, F, or maybe let's swap the last 2 so that the cofactor stays the same.
I don't think. Yeah, sure.
Yeah, we could just, because I always understand the first row to be the cofactor. So let's just swap this. So G, H, I, D, E, F, yeah. And then, sure. So when I do this cofactor, this minor is HF minus EI, but this one is EI minus HF.
Yeah.
Okay. How do I write that in terms of math language? Because I just want to say, like, I just want to be like, yo, dog, it's opposite, right?
Yeah.
Nice.
Yeah, that's what I'm thinking as well.
Okay, it's all good. Matrices, my beloved.
So the minor in C, right? So the C prime would be -1 to the power R plus K times another matrix in the same position.
Okay.
Do you remember our formula for?
I remember this.
Yeah.
Yes.
Yeah. So it's -1 to the power of its indices. So it's gonna be C prime is gonna be C prime RK is gonna be.
Oh, I see.
-1.
C prime RK is going to equal to -1 to the R plus K of C RK.
Well, it's not gonna be CRK. It's gonna, let's say MRK because it's gonna be another matrix.
It's another
we have to be
matrix.
careful.
We keep making more matrices.
This is the problem here because there's gonna be a lot of matrices that are very similar to each other. So we cannot denote it the same.
Yeah.
Right. So what this minor, it just basically deletes the row R from C, and it also removes the row that used to be R plus 1 from A. Right. So the remaining ones should just be those of A with row R in one position lower than before. This is how I understand this.
Okay.
So from an n-line matrix, we basically just shrunk it down to an n-1 by n-1 minor.
I agree.
Yeah.
Okay.
So it's a single row swap. So then, if we do the same thing relative to the minor at R plus 1 and K, so instead of M
Okay.
of...
So like C prime of R plus 1? Okay.
I'm thinking of the minor in A, no longer C prime. I'm thinking of C right now.
Okay, so then that's
Right,
CRK.
CRK, right?
Yeah, CRK, yeah. Is equal to -1 to the R plus 1 plus K. Is that a different MRK?
I believe...
Holloman really wants to do it in terms of summation notation and Levi-Civita.
I don't know math that well to understand what that means.
You know so much math. Stop it, Narosky. You know so much math, dude. Let me just like show what Levi-Civita is real quick for people.
This is so annoying because it's so much notation.
Yeah, this is like tensor. EIJ is +1 of IJ, -1 of that, 0 if I equals J. Oh my god, dude, what's going on here? What's going on? Christian, what number Q you are? You're number 4, Christian. Don't worry. I might give this one like a couple more minutes and then like I'm gonna maybe... I'm so sorry, Fresh Canned Peaches, that this is your linear algebra class. This is garbage, dude. What? This is insane. Did anybody in any sort of linear algebra class have to prove this? Zach, did you? Zach taught a linear algebra class, didn't you, Zach? Or was that Penn Center?
I don't think I had to prove this.
I don't think I had to prove this either. Okay.
Yeah, this...
Let me throw this at AI just for a second. Just like see what it comes up with. Maybe it has like a nicer... I like your interpretation. And I'm learning a lot from you. But the notation sucks.
Yeah, it's a lot of notation. It's
let's go burn some... I did this in my linear algebra class, but this is not an endorsement. Oh, you did, Mathematic Fanatic. That's cool. I have notes on this, but it's in Einstein notation. Yeah, see, yeah, Einstein notation's crazy. This is all like, what would you call this? Like quantum mechanics almost is what this stuff is.
Yeah, it's used a lot in quantum mechanics.
Don't worry about what Einstein notation is, Zab. Yeah, it's very, very, very weird math stuff. Einstein notation is great. It just drops the sigma. The sigma is implied. Okay. Gemini did using the base case n equals 2. Showed that. And it showed if you swap it, you get -1. Okay. So inductive is assume for any n minus 1 my n is 1 matrix, swapping 2 rows multiplies the determinant by -1. They use the cofactor expansion along a row that was not swapped. Since n, what's the sigma? Since n is greater than or equal to 3, there's at least one row k such that k does not equal I and k does not equal j. I think this is kind of what you're saying here, Narowski. But they're doing it for something greater than 3.
Yeah, well, yeah, of course.
Right? Because then you can find 2 rows. You can find 2 rows that aren't being swapped, right?
Yeah. But this isn't. Well.
Oh, and then what you're showing, Narowski, is that the swap has to occur in the minor. And then because we showed for a 2x2 that if you swap a matrix, the determinants are negative, that tells you that the minor is swapped. That the minor is negative. Oh. Okay. So yeah, Narowski, they didn't go to a 3x3, or wait, did they go to? Sorry, they did go to a 3x3, or I thought they went to. No, okay, they did go to a 3x3. There's at least one row such that k does not equal I, k does not equal j. Let's expand our long row k, where akm is n minus 1 by deleting row k and column n. Oh man. Let's see. Fresh Canned Peaches says, I'm kind of getting it, but I got tested proofs just last week, and it gets confusing looking at a bunch of sigmas and matrices with no numbers in sight. I'm an engineering major, not a math major. Yeah, Jesus, dude. This is very difficult for an engineer. Yeah, this is not engineering core math. Proofs suck. Okay, just in the interest of time, I'm gonna keep moving forward. But if you want, Fresh Canned Peaches, I'll post the link for this at least. And then I don't know if Narowski already has like quite a queue of questions he's working through, but if he wants to do this one, you can. Otherwise, don't feel pressure, Narowski. I know it's a lot of like ugly notation. It's a lot of ugly notation. How do I share things? Even the bot said no. What's up, Narowski?
What I'm trying right now is like, you know how instead of just writing out a matrix as A, B, C, D, and so on, I'm denoting the rows as R1, R2, and so on, so it's just a vector of rows. I think it's easier to understand that way. Okay. Instead of, because we're not working with elements, we're working with rows, so I think it's easier.
Okay. I think that's kind of what they did here. Yeah, they talk about rows and columns. Okay. All right. I'll post the question at least, and then we'll go through it. Oh, just ignore the angle part, Otis. Okay, cool. Yeah, Otis, why is there tension in the ropes though? I think that was my question on yours. Let me start real quick. But okay. Let me mark that one as done, Dane. Dane, if you're part of our Discord, I highly recommend you join it, because that's where we'll post all the conversation about your question and what we got so far. And then Narowski might post a solution in there as well. Oh, you're on the same. Okay, cool.
My man.
That's awesome, Dane. Very good. Love it. I'm going to post it in there. Because the object has inertia? Oh. Solid state. Pineapple's asking about solid state. You want to post an example question, Pineapple? Post it in the queue? Here, Dan, I'll give you a point also, because like I'll count that as a question. Dane. Wait, what's your username? Dane? Oh, it's Fresh Canned Peaches. Sorry. There you go. Got it. That's I like Fresh Canned Peaches. You're lucky. No optics questions today. Thank God, dude. One second. Let me go through all my chat. There's a lot going on in chat. Holloman, you love solid state. Well, if you want to join our Discord, we do have a student who's asking about solid state. I think in terms of chemistry. I did like some solid state physics, like Briand zones and lattices and stuff. How it impacts society and the environment. Okay. I mean, solid state stuff is used for everything. I mean, that's how, like, I don't know, electronics work. Do you guys solve the induction question yet? We're still working on it. I'm gonna move forward to just help out, just in the interest of time, because I'm running out of time. I want to make sure I can go through everyone's questions. It is on our Discord though. Yeah, please join. Yeah, please. Yeah. There wasn't enough source internet. Article is limited. Dude, Pineapple, dude, what? The internet is infinite. What do you mean there's not enough information? But yes, if you go here to this website where people are submitting the questions, actualofficehours.com, and click join our Discord, that's where you can see all the questions we're running from. You are next, One Zab. Let me do yours. One Zab, here we go. Is this an integral we're doing? This kind of looks kind of fun. Pineapple, post me a screenshot of what you're trying to go through, and maybe because we have people in TikTok who might want to help you as well. Okay. What is this notation, by the way? So that's the proof that projectile motion has parabolic shape. I was looking at it and wondering about integrating it. Okay. What are these things though? what is this? Is that's tangent of SX, tangent plus SY? Yes, I do want to see the proof, please. Proof that projectile motion is parabolic. I mean, I know it's parabolic just from like doing derivatives and shit. Like what? Why is there tangents involved? I think S is a reference. Yeah, probably. There's some, but not enough, like lithium ions. Well, yeah, rare earth metals are about to become a big issue.
Surprise, motherfucker.
Go talk to China, dude. Why do you think we want Greenland? The tangent doesn't matter. But yeah, this is where I'm like a little confused here, dude. Like what? Why is there tangents involved? Projectile motion's pretty easy, right? Okay, all right. I got tangent because sine over cosine. Trig identity. Yeah, Otis, I don't exactly understand your question, to be honest. I'm a little, yeah. I know it's a fun little thing you came up with, but I'm really confused that there's like, what, there's an object here being pulled, but then where are the pulleys? Are you saying that like this is like connected to a pulley like this? Oh, nice. Narosky already has a derivation.
Well, not for...
Not for this.
For the,
no, I have no fucking clue what this thing is with the pulleys.
Yeah, this is what I wanted to show all along, but I was getting confused by notation.
You're okay. Okay, so this is.
Yeah, I think it's nicer to look at it like this.
I think it's nice too. I think it looks really nice. Here, let me paste this in real quick. Are we integrating? Yeah, everyone's confused. I know, because I'm bouncing between like questions. One sec. I will choose a question that I can actually solve in a second here. Let me just look real quick at this thing for that Narosky wrote up. Where can you join the Discord? Same link you submitted the screenshot at. There's a link. Yeah, you can totally here. You know what? Yeah, click here on join our Discord. I'm gonna take your question and I'm gonna post it. In our so everything will show up in our homework help thread here. If you go to homework help, Right here, one zap. This is yours. So there's a nice little thread here. You can like post whatever you want, and as long as it's related to the question, and I'll take a look at it. Cool, perfect. All right, let me look at what Narosky, because Narosky did take time to write this. I want to see what it is. Okay. A is okay. I see. Row 1, row R plus 1, blah blah blah. Row N, and these are the column vectors. Okay. So, wait. No. These are two different matrices. Oh, I see.
Yeah.
Matrix A, matrix C.
I should have swapped R.
You want to swap
plus one,
these?
yeah.
Yeah, it's okay.
Yeah,
I got you. This is R plus 1, and then this is R of R. Yeah, got you.
Yeah.
Okay. Row R of C is RR plus 1, and the determinant of C is the sum. Okay. Of A, R plus 1, K, C prime R of K, composing M prime. Comparing.
Yeah.
M prime RK and M R plus 1K. Okay, where M prime is for matrix C, M is for matrix A. Fix a column K. Right, okay.
So what I tried to say here, so I can explain it better, is the minor. So M from minor. That's why I chose A. So A is minor.
Okay, M is the minor.
So the minor of matrix C at position RK is the n-1 by n-1 determinant that is obtained by deleting the row R and column K from C.
Okay.
But what is the row R of C? It's the row R plus 1 of A.
Okay.
Right, so practically what the AI was saying as well was that removing that row is also removing row R plus 1 from A.
Got you. Okay.
If you look now at the rows of C and well, not C prime, sorry, just of C and A.
C.
Of C and A, you will notice that they are the same.
Okay. Since column K was deleted. Okay. If A and C now have the same rows.
Yeah. So then, therefore, the minors should be the same.
Okay. The minors would be the same, but then the cofactors are opposite, is what you're saying.
Exactly. Yeah. That's what I did there. Some algebra to prove that the cofactors are opposite.
Oh, okay. Got you.
So what happens if you have the same minor and the opposite sign at the cofactor is that the determinant is the negative of each other. Like the determinant of C becomes the negative determinant of A.
Okay. I see.
So this is basically, this little thing is what you're going to use to do induction over, right? So I basically just did the difficult part. Now you just suppose
it works for a 2x2. Show works,
yeah.
Okay, cool. I see. So you said the minors are the same. You're just showing that the cofactor, because it like increases by 1, then that cofactor is negative. Okay. Yeah, so I think I understand that more.
What induction should look like here is suppose for any A and B. Suppose for any matrix A, if B is obtained by swapping rows I and I plus some number T, let's say.
Yeah.
Then the determinants are opposite, and you're going to use the fact that if two rows, what I just did is two adjacent rows. You're going to show in induction that it doesn't matter which two. It doesn't have to be adjacent.
Right. I see. Okay. Cool. I think it makes more sense. Fresh Canned Peaches says, "Oh, okay, thank you. I get it. Y'all are lifesavers." Nice. I'm not a lifesaver. Narosky's the lifesaver at this point. I'm just trying to learn. What were you gonna say, Narosky? So?
I was gonna say that the only difficult part here is gonna be showing that like how it matters how you choose your indices such that you prove at the same time that it doesn't have to be two adjacent rows for it to happen.
Okay. Yeah. Yeah, they don't have to be right next to each other. You can show that's like for any two. I guess you could just always like wait, because aren't matrices? No. You're right. Swapping rows switches the determinant. That's so crazy that it does.
Yeah, and if be careful if you swap. Let's say you swap row 1 and 2, and then swap row 3 and 2.
Does it become positive?
It's going to be the same. Yeah, it is
Yeah.
the same.
Yeah. Because you swapped it twice.
So yeah, and for example, if you swap row 1 and row 3, but then swap column 1 and column 3, the determinant is going to be the same.
Oh. Wait. So
because it happens for columns as well.
Oh my god.
Yeah.
Dude, this poor kid though, poor Fresh Can Peaches, being an engineering student, getting thrown into like the lion's den of like math classes. I feel so bad for you, Fresh Can. I'm sorry. You'll get through it, or you won't.
Surprise, motherfucker.
Okay.
I think when these huge like summations happen, like it's the most difficult part of algebra.
Yeah. Zach says the lion's den is functional analysis. I don't even know what that is. Yeah. Yes. Let's do some. Okay, but now we have a nice question here from or algebraic topology from Flore. I love this. This is great. We love this. This is all right. Back to normal land of math. I know some of you guys have been like, "Yo, what the fuck's going on?" It's okay. I like doing the high level stuff. It's fun to see. Because I learn. But also I want to like make sure students know you can ask easy questions like these too. These are totally fine. Trust. I believe in you too, Fresh Can Peaches. I'll manifest it for you as well. You're gonna get an A. No, it's okay, mathematic fanatic. Yeah. Okay, Crispy says, is the answer equal to C? Probably. Let's see. Yes, the answer is equal to C. This is called exponential form. And if you want to see like why this works, so A to the B is equal to C. You can always take the log of both sides, but you always want to be clever and try to take the log of what this base is, right? So I would say, okay, let's do log base A of this, and then let's do log base A of this. When you have the log of something to an exponent, the exponent comes down out front. And then when you have the log base A of A, this ends up becoming 1. Okay? So this is why you end up getting B is equal to log base A of C. Which was answer choice C. Correct. The other way to do that, I mean, if you really wanted to, you can go through every answer choice. This is whenever you have, I think they call it BAP. Log base B of A is, or is that what log base B of A is equal to P? Yeah, they call it BAP. This is the same thing as saying B to the P is equal to A. Yeah. Not a marketer. This is an interesting concept. What's your background? I teach physics and everything else, math and science. And this is a nonprofit. If you want to know more about like what we do, because I know a lot of people ask me like who the fuck are you? What's your background? Go to the website actualofficehours.com. Click here on bio. You click on bio right here. This will give you my link tree, so you can go find my LinkedIn. Let's go be friends on LinkedIn, please. I need more connections. And then you can also look at the pitch deck. I need to update this. I'm gonna update this pitch deck, but this kind of shows like who we are and like what we do and why we do it. And then there's a website if you want to find out more about what we do. We have a website as well, so go check it out. All right, I hope that makes sense, Chris. What's up, Narosky?
I wanted to add that for Fresh Can Peaches, like you shouldn't worry because using that formula for any matrix determinant is the equivalent of using the quadratic formula to solve x squared minus 1 equals 0. So you're never gonna use it. Right? So
So Narosky just said, yeah, that whole thing we did with the matrices is just overkill. Just absolute overkill.
Yeah, it's just for fun. Like you just want to prove a concept that you know. It's
kind of a
is
sick
true,
understanding
right?
of fun, though, dude. What? That's I don't know, like who in their right mind thinks that's fun, dude. What?
Like the only way you're gonna use that formula ever, the cofactor expansion formula, is gonna be like if you actually go down the path of mathematical analysis.
Yeah. If you're going down that rabbit hole.
Yeah. The only takeaway should be that the row change makes the determinant become negative.
Yeah. Gladiator asked if you're a professor. Gladiator said, is
I'm
Narosky
not
a professor? Narosky is just fucking brilliant. But yeah, Narosky is in high school, but in Romania, and a super genius. So he knows more math than I do, honestly.
I did teach a few kids at like a summer camp one time.
Okay, so yeah, he has been a teacher.
That's about it.
And actually, stay tuned. Please join our Discord, follow all our things, because yeah, Narosky is actually going to have a segment on our streams on Friday where we're gonna do like all like the really cool, beautiful, elegant math and like competition math questions. He actually writes competition math questions himself, so I highly recommend. I'm gonna announce that later today. I was waiting for Ramton to confirm with me about Saturday, but whatever. I'm gonna announce it. So come by on Friday, and me and Narosky is gonna basically teach me like how to do math the non-American brute force way. We love just like hitting things with a hammer, like make it work. Otis, I'm confused. Otis too as well. I'm confused at your question as well. Let's just go with that. I'm also confused. What are they feeding them in Romania? The threat of back in the day they fed them the threat of being conscripted into the military. Yeah. Narosky will tell you. I mean, because I told because I had a Romanian cello teacher, and he told me about how the reason my cello teacher became so good at playing cello is that it was either that or you were going to get sent to the military. So there's a pretty big motivator to be good at something that's not going to put you in the military. One zap. I did not yet. Let me make sure I get through everyone's questions real quick. One sec. Let me do this. Let's do this. This is from Chris. It's definitely some motivation. Yeah. I don't know. Yeah, I would say kids these days, myself probably included, we probably have it like pretty easy. There's not really much of a threat. There's the whole argument, right? The carrot or the stick. I'm starting to lean towards the stick. Because the carrot, I don't know. I don't think kids see what the carrot is anymore. And I understand, because like it doesn't look like there are any carrots out there, right? When I went to high school and college, the carrot was, do well in school, get good grades, you'll get a wife, 6 figures, and a house. And then here I am at 35, and I have none of those 3 things.
Disqualified.
So I understand. I understand that kids these days don't see much of a carrot. So maybe we need to like reintroduce the stick. Yeah. Or they're multi-live vampires. Narosky, you've lived for 500 years apparently. Okay. Let f be the function given. Estimate the value of f of 2. Love this. These are so nice. I love this. This is like a nice warm bath to do these questions. The problem, Mathematic Fanatic, is I don't know what the carrot is anymore. I can't like tell kids to go into STEM because like I can guarantee you're gonna have a nice job, because that's not really happening anymore. It's like I used to tell kids learn how to code. I still recommend you should know how to code, but it's not gonna guarantee you the nice job that it used to be, because AI or some dude on an H-1B visa is gonna take it from you. The carrot is your identity. We'll eventually get there. Yes, I know. But even that's a lot harder to like show to people. We're getting there. Billy Sigma, yeah. The best way for us to go through questions again is to go through the queue. You can put things in that forum, totally cool. But I go by the order of like people submitting things in the queue. So let me do this real quick. All right, this, yes, around 2.75. Estimate the values of x such that f of x is equal to 3. Cool, that's not too bad. So f of x is the same thing as just saying y. So y is equal to 3. Good night, GMAT, dude. Good to see you, bro. Appreciate you being around. Here, let me give you a little bit of a plug, though. Sorry, let me give you a plug. What's your TikTok again? TikTok. Let me show people your TikTok, because I appreciate you're also doing fun stuff on TikTok. The best GMAT prep. Where is it? I think I better be following you. What's all this garbage, dude? Where's best GMAT? There we go. Is this you, Brian? This is you, man. Oh, hell yeah, dude. Yeah, I remember when I was first talking to you. Yeah, you only had like a couple hundred views. Now you're getting a couple thousand. Yeah. Good shit, dude. Keep pushing, dude. Keep doing this stuff. Nice. I like these videos.
To getting over 700 plus on the GMAT, part 4. My name is Brian from Best GMAT Prep.
Good shit. Yes. I like what you're doing. Keep at it. Eventually, dude, I've been doing this for like 5 years. First year or two, I was talking to the void, dude. Talking to nobody. Now I get to talk to all you guys. Great. Estimate the formula. It's just sine of x, right? All right. This is 3. So, like, where does this happen? I don't know. It happens around, like, 2.1-ish. Yeah, no, seriously. Yeah, no. I had very, very little views. 1, 2, 3, 4, 5 and a bit. I do have the soundboard to comfort me.
My man.
Yes. Even if I talk to the silence, I can just talk to myself. Yeah, no, it's a grind, fanatic. It really is. It's a super grind. You just gotta keep going. Domain of F. That looks like all real values, right? Domain. That's just all real values. Or I guess the way they probably write this, and this looks like probably a high school question. You'd say like negative infinity, comma infinity. Because it looks like there's no breaks. You know, there's nothing, there's no discontinuities, so you can probably just do all x. The range, though, okay. Well, this thing looks like it tops out at 4, right? Positive 4. It looks like it bottoms out at like negative 4. So the range there is probably negative 4 inclusive. You gotta put brackets here. Be careful. Jeff, yeah, Jeff's probably right. And then comma 4. And then on what interval is f increasing? Well, here it's flat. Here it's flat. So it must be increasing from here to here. So that's around 1, 2, 3, 4. So also from negative 4 to 4. That's actually kind of funny how that is. But it's not, but it is neither increasing nor decreasing at negative 4. So you have to put parentheses. Parentheses means it doesn't include the value. Bracket means it does. My music is slapping. Praise Suno. Because I couldn't find, I'm a musician myself. I produce music myself. But AI music is great for this fucking copyright garbage shit. Like, if you just want to be a streamer and just have some nice background noise, it used to be anytime you tried to find anything that was like copyright free, someone would just claim it and then your stuff will get struck down. It was the worst. So, this is AI music, so no one can claim this shit. Anyways, good stuff. I do start prod. Good question, Chris. You're very welcome, Chris. Are you in our Discord, Chris? Because you get credit for this, for asking this question. If you're in our Discord, just like the post when it comes in. Thank you. You have a great rest of your night too, dude. Yeah, join. Yeah, please join. Please join. You get rewards. So yeah, if you're a student, so our nonprofit, we do this. We teach kids for free. We have this fun little stream. We do a lot of other activities. And you can earn points for doing those things. And then when you get enough points, I buy you gift cards. So it's pretty dope. Yeah.
Nice.
And it's not a scam. It's all free. It's charity. I use Ableton. We've had some music production streams actually in the past. I don't know if you've seen them before. If you go to our YouTube channel, where's my YouTube channel? There we go. My channel. Hit search music production. I used FL when I was in like middle school. Ableton's expensive, I understand. But yeah, here we had a music production stream here.
You can save this and just.
This is an example of one.
Hip hop-ish, type of thing.
One of my other producer friends, we were in the studio here, and I was showing the students how you can produce music in Ableton. It's cool. FL's great though. It is, dude. I love this. Wait, someone sent me this as their screenshot. Consider the following equations. Wow, this is so fun. Dude, I love this. Wait, what? Is FL better than GarageBand? I think it is. Although, some cool albums have been made out of GarageBand. It says it's a level 1 difficulty, so I don't think this is too bad. Submit it in the website on the screen. Alright, let's see. Yeah, you can also definitely torrent Ableton if you want to. Multi-talented. I do a lot of different things. I think yeah, hobbies are the spice of life, man. I think it's cool to have a lot of different interests. Use chat to extract the text. I could. This is okay. You know, this is fun from actually. This looks like this is relativity. This is special relativity, right? Because usually V over C is equal to beta, and then this is square root of 1 minus beta squared. This is special relativity. I think these are, I want to say, Lorentz boosts. Yeah, right? Yeah, right, Holloman? Yeah, these are cool. This is where my physics degree comes in handy. I do recognize this stuff. Einstein mentioned. Yeah, okay, cool. Find an expression for wx squared plus wy squared. Okay, cool. Let's just square it. Kind of messy, but whatever. So c squared cosine squared theta plus v squared minus... Oh man, do I really want to write all this out? This just really sucks. It's just algebra. Yeah, you've definitely seen this on your equation sheet. Yeah. Let's here, let me call things. I'm gonna call this equal to A, because I just don't want to write all the other stuff. I'll call this equal to A. Okay. C squared cosine squared theta plus V squared minus 2VC or 2CV cosine theta. In Quebec, there's no 12th grade. It's kind of the same thing in the UK. They have like A levels and O levels. They also have like kind of an interesting system. And then this would be over, I'm going to say A squared. And then we're going to say plus, and this is going to be gamma squared. A squared. And then this is just going to be C squared sine squared theta. Okay. Now here's a cool thing. Gamma is actually 1 divided by something. So actually gamma is actually going to like throw some shit up top. So gamma squared is going to end up being... Okay, because... Here, let me move this. Thank God I have copy paste, because it would suck to write this all out again. I'm going to say plus the square root of 1 minus v squared over c squared. And then we're going to say... Oh, and that's squared, right? And then we're going to say c squared sine squared theta. And then this is all over a squared. Beautiful. Right? And that came from this. That's where this came from. Okay. I see I see something maybe happening.
I think you're complicating with notation.
Am I complicating notation?
Yeah, I think like you denoted v over c equals beta, but you didn't use it, and you denoted the...
Oh, no.
I
I don't need this. Yeah, no. I just said this because this is cute, but yeah.
Oh yeah, but is it not easier for you?
It could be.
Let beta equals to v over c, and you said a is equal to 1 minus beta cos theta, no?
Oh, okay. I see what you're saying. That's actually yeah. You're right, Narosky. You're right. When you're right, dude. I agree. Okay.
So a
but
is
I have
just
like
1 minus beta cos theta, right?
Yeah. So A, let's write that in a different color. A is equal to 1 minus beta cosine theta. Okay.
Yeah.
When's the next stream?
Gamma,
tomorrow.
Yeah.
Okay. And then gamma
is just 1 over 1 minus beta squared.
Okay, right. So gamma squared is just 1 minus beta squared.
Yeah.
No, 1 minus... Yeah, 1 minus beta squared.
Yeah.
Okay, cool. And then... Here, we're going to write this
WX.
as... Sorry, and then A was 1 minus beta cosine theta.
1 minus, yeah. Could you separate for me, please, Wx and Wy so it's easier to see? Like, say Wx is equal to something, Wy is equal to something else?
Yeah, for sure. So Wx is equal to C cosine theta minus V over 1 minus beta cosine theta. And then Wy is equal to C sine theta over gamma 1 minus beta cosine theta. But then and then gamma is, well, gamma's ugly as fuck, so I don't really like that. We're just gonna leave it like that.
Okay, well,
I see that, like, I have a C,
WX
I have this C,
Yeah.
C squared sine squared theta and C cosine squared theta, which is nice, right? These are gonna be nice.
What I notice is Wx is just C multiplied by cosine theta minus beta over
Okay.
A.
Wait, this has a cosine theta, this has a sine theta on it, though, no?
Yes.
Okay, so what would you say, sorry? Wx is equal to what?
I'm actually gonna write it out for you because it's short. So I'm gonna say
Alright, right after me.
cosine theta minus beta over A. I think you denoted it as A.
Yeah.
So it's gonna be like, it's gonna be this.
Let's see.
This is what I see. This is the first thing I saw.
Okay, Wx is equal to C cosine theta minus, oh, beta over
Beta.
A. Yes, okay, sure. It would be 1 minus beta squared right here. But that's gamma squared. Gamma has a square root on it.
Yeah.
Cool shapes. Sure. Okay, sure. Yeah, this is C, and then, yeah, cosine theta minus beta over A. And then,
Then
well, this
what
doesn't-
would be Wy?
Wy is just a mess. Well, Wy is just equal to C sine theta over gamma A.
I want to get rid of that gamma because we know stuff about gamma.
I do want to get rid of the gamma too. But so
Yeah,
gamma is equal to 1 over the square root of 1 minus beta squared.
So then just multiplying by the square root of 1 minus beta squared, it's just gonna give us, yeah.
Yeah, so this is square root of 1 minus beta squared.
Yeah.
Okay. Okay, and now when you
So
square
the-
these and add these
yeah.
together, this looks a lot nicer. Yeah, okay. I agree.
Yeah, this is what I,
This is ugly. This is where, dude, yeah, this is, again, I love it, Narowski. You have such a more elegant way of looking at math than I do. And I hope to learn more from you.
Yeah, I always think about separating stuff. So since like they gave us stuff separated, we don't need to combine them. Right?
I was like, you know, we can just Northrop Grumman our way through this and just figure it out eventually.
I think you could have done that, yeah.
I could have done it,
like,
but this looks nicer.
Yeah.
This looks nice. I agree. Because this becomes C squared cosine squared theta minus C squared beta squared, or sorry, plus C squared beta squared minus 2C beta cosine theta, right?
Yeah.
Plus C squared sine squared theta minus C squared sine squared or C squared beta squared, right? Sine squared theta. And then this is all over A squared.
Yeah.
Okay. So this is 1. That's what I wanted to see. I was like, cool, this is great. This is 1.
Can we not divide by C squared?
Yeah, we can divide by c squared. What is a squared again? Sorry, but a is messy, dude. A is so messy.
Yeah. Notice how it asks for.
Well, eventually it wants things in terms of VC or theta.
Yeah. So just divide by c, because it's easier.
Okay. Yeah, we can divide by c. That's fine.
You can actually divide by c squared actually because you can pull out a factor.
Not for this term though.
Oh right.
Right. Yeah. This is the cross term here has just a BC in it. Beta
Wait,
c.
Can you?
But then beta's v over c. Oh, so then it's just a v. Right? No, but then it would be. Oh. Is this calculus? I don't know what this is. It's c cosine theta. Well, okay. If this is v over c, right? You end up just getting v. But then if I divide by c squared, that's going to be v over c squared. Right? It is very ugly algebra. It's fucking hideous. Maybe like we should see what a squared is. Right? So a squared is equal to 1 squared plus beta squared cosine squared theta.
I'm convinced that you can pull out a factor of c squared because if you square vx and vy, actually wx, wy, you have a common factor of c squared. Like if you don't expand the parentheses.
No, but you oh, okay. You're right from here.
Yeah,
you're
from
right.
those two, you'd have.
You're right.
You'd have a
You're
common
right.
factor of c.
You're right. Oh, so did I fuck up somewhere?
I'm not sure. I don't think
No.
you did.
I don't think I did.
No, but if you expand, you do end up having stuff that isn't. I don't think you should end up having stuff that isn't c squared.
That isn't c squared. I agree. Nicholas says,
Yeah.
"What website is this? I need a better one for tutoring." This is Actual Education. Come on by. We do free tutoring on Twitch, YouTube, TikTok, Discord, all the stuff, 4 times a week. So, yeah, go make sure to go at us. The website's down there. Okay. You know what? You know what? You're right. I fucked up. This is c squared beta. Sorry. You're right, actually. Yeah. I forgot to multiply by c squared. You're good.
Yep.
Oh, the drawing app? It's just called Group World.
Wait,
okay.
One second. I have it written out for you, if you'd like it.
Yep. Thank you. Yeah, just save me.
I had to
Save
make
me
sure I
from
had it
writing
for
all
you.
this. It just sucks. It just sucks.
Yeah, I hate algebra, like lengthy algebra, as much as the next person. So I just look out
Yeah,
for
it's just
shortcuts.
so bad, dude. It's so bad. Okay, whatever.
This is what I saw intuitively. Like I wanted to divide that by c squared, so we no longer have c squared.
Okay.
So if you divide both sides of the equation, like you divide w squared and the whole big thing on the right hand side by c squared, you'd have
Yeah.
something nice.
Yeah, okay. So what you're saying, like w squared over c squared?
Yeah.
Okay, fine. W squared over c squared is equal to cosine theta minus beta squared plus sine squared theta 1 minus beta squared. 1 minus beta. Beta squared.
1 minus
Not
beta squared. Yeah.
Okay, and then this is all over a squared.
Yeah.
Sure. Okay.
Sure. I think we just expand now. I don't think there's any tricks anymore.
Yeah, I don't think there's any more Narowski tricks here, right? So, yeah. Cosine squared theta plus beta squared minus 2 beta cosine theta plus sine squared theta minus beta squared sine squared theta?
Yep.
All over
That's
a
correct.
squared? Cosine squared, sine squared is 1. That's what I really wanted that, dude, honestly. So now we have 1 plus beta squared minus 2 beta cosine theta minus beta sine squared theta all over this ugly as fuck a squared, which a squared is equal to all this.
Beta squared. Don't forget the beta squared.
Yes. Correct, Nowski. Good, thank you. Okay. Okay,
Right.
now
Okay.
do you think we just, well, can we pull, no, we can't pull a beta out of everything, can we?
Wait, can you delete the red text? Leave it as A.
Okay.
I just saw something. Yeah, leave it as A squared.
You want to pull a
And
beta out?
notice, no, yeah, beta squared. But don't pull out of everything. Factor the terms that have beta squared in them. So
Sure.
you'd have, right.
Okay,
you'd
so I
1
have,
minus 2 beta.
so I have beta squared, and you're going to say like 1 minus sine squared theta? Oh, nice. Yeah.
Yeah.
Okay, great. Excellent.
Yeah.
And then you're going to say plus 1 minus 2 beta cosine theta all over a squared. This is cosine squared theta.
Yeah.
Okay, cool. Plus 1 minus 2 beta cosine theta.
Notice how this is a difference of squares? Actually, not difference of squares. It is a square.
It is a perfect square trinomial. That's actually really cool. Fuck, that's dope. Yeah, because this is plus 1 squared. Holy shit.
Yep.
Oh, wow, okay. So this is 1 plus beta cosine theta squared.
Minus. 1 minus beta. Cosine
Sorry,
squared.
1 minus. Oh, my God. 1 minus beta cosine theta squared all over a squared. But wait, what was a?
Exactly.
Oh, man. A was it's like way over here. A was 1 minus beta cosine theta. Oh, okay, great. Okay.
Yeah, so that's just 1.
Oh man, dude, this is so pretty. Okay, but A equals 1 minus beta cosine theta. So you literally just have 1 minus beta cosine theta, right?
Yeah,
Wow.
so it's
That's
just 1.
super cool. The whole answer is just fucking 1?
Actually, the fraction.
Oh wait, no. That was equal to omega squared over c squared.
Yeah.
So omega squared is just equal to c squared.
So we just have the speed of light.
Great. Wow. See, I knew it was something with like relativity. That's hilarious though. Whose question was it? Fuck, who was that? Jonas? Jonas. That looks so scary at first. Okay, I'm picking up. So, you know what was cool there, Narowski? Is that we combined my knowledge of special relativity with your elegance of math to then...
Yeah, that's very nice.
Yeah. Would you have known to call beta V over C?
Absolutely not.
Oh, okay.
No, I would have never thought.
Yeah. That's. I mean, you probably would have assigned it to a variable for sure. I think you
Yeah,
might have.
yeah. At some point, but not that quickly. Like noticing stuff like that is comes with experience.
Yeah, exactly. Yeah. The noticing. I noticed this. I was like, what? That bitch is beta. Funny. Okay, cool. Good question there, Jonas. All right, we got 8 minutes left. Let's see what I can do. Next 8 minutes. This
I have
one.
this solution.
Okay, let me post it.
Yeah, let me put it in chat.
Okay.
1 second.
Thanks. Gladiator Leos, did you have another one for us? Something with electrons? Oh, this is a fun question. I know this one, Gladiator. Let me see 1 sec. And Lucky Cat was asking for an assessment of how solid state batteries impact society and the environment. They fuck up the environment for sure. Yeah. Oh, okay, nice.
It's 2 photos. Because I went out of my way to explain like stuff because I didn't know how much he knew.
Got it. Thank you. GZ Dizzy, Narowski has written up for a beautiful solution for your question right here. Okay, cool. And then Holloman, what you got for me, dude? Charge particles. Quadrupole field? Whoa, Holloman, whoa. I don't know if I can do this in 11 minutes.
I believe it.
Ba, ba, ba. Ba, 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 ba. Is this just QV V cross B? Is this some equation of... I think it's like some equation of motion that happens. Let me see. This question is very related to what Gladiators was. Let me just do this one real quick, because I know I can do this one. And then I will think about yours, Holloman. I'm not sure I'll be able to solve it. But yeah, Pineapple, I think there's a lot of information. You can literally just say, like, yeah, solid-state batteries require a lot of rare earth minerals, which are very taxing on the environment to, like, come get. Oh, it's an analytic mechanics. Yeah, I see it. What you're going to do probably there is write out, like, sum of forces is MA, right? So what you have in, like, and again, this is what this question is, okay, is that you have F is equal to QV cross B, right? Where F is the same thing as MA. So MA is equal to QV cross B. And then this is, exactly. Oh, and there was an electric field as well in your question, Holloman. Welcome back, Nards. Oh, no, I don't think that. No, there was no electric field for this one. For this one, I think there was an electric field. Yeah, right. Yeah. And then A is equal to X double dot is equal to Q, and then this is X dot cross B. And so then you have to come up with, like, some equations of motions that make this work. Yeah, yours is just magnetic field. This is called, like, the Lorentz force. But then you can have this, for instance. This is like the full motion of a particle within a electric and magnetic field. Yeah, I think that's what you do. You use, like, QV cross B, and then you're gonna write out, like, velocity's derivative of position, acceleration is the second derivative of position, and then it's there's some tricks. It's like Lagrangian, Hamiltonian, whatever the fuck's. Nards, am I talking about the problem you posted? Well, there are a lot of problems. Let me do this one. I know how to do this one real quick. An electron travels between two parallel charge plates as shown. It would be nice if I knew what they were shown, but it's okay. Let's assume that this is the positive end, this is the negative end, and that there's 200 volts. And then you want to know what magnetic field strength and direction will allow the electron to pass between the plates without being deflected. Oh, very cool. Oh, okay. Well, in this case, you just need QE to equal QV cross B, right? So you just need the... So when a charged particle, such as an electron, moves through an electric field, right? Say this is E. And let's say it's moving this way. It's going to get pulled up towards the positive plate, because that's just how electric fields work. Yeah, exactly, right. So this is going to, like, pull it up, right? But so that's the force due to an electric field. So that's F is equal to QE. And in this case, electric field is equal to potential divided by distance. So this is Q potential over distance. So that's going to be Q times 200 over 0.01. Okay. So that's the electric field. There's another property, which is called the Lorentz force, which says that F on a particle is equal to Q, and then it's V cross B. This V is velocity, not potential. So be careful. I know we start using the same letters in physics all the time. And so in this case, the velocity vector is pointing this way. and I need a magnetic field such that when I cross the magnetic field vector with the velocity vector, that I get an opposing force. So let's think. So in this case, and they both have Q's on them, so actually I don't care what the charge of the particle is. That's going to be canceled out on both. The electric field here points down. So I need this net force to be up. So by the right hand rule, again, let's just assume the charge of Q cancels out. It is flipped, but also this is going to be flipped. So I'm going to assume that I'm going to assume that I'm going to pretend it's positive. Because this is negative and this is also negative. So if I'm setting them equal to each other, right? Okay, maybe we don't want to confuse people with that. Okay, that's fine. That's fine. Electric field is pointing down, but the charge is negative. So this is going to be up. Okay, you are right. Okay, this is up. Okay, so then I need this to be down. Okay, where this is going to be negative. So I need V cross B to be up. Right? Because I need the overall force here to point down. But there's going to be a negative on the Q here. So then I need this to point up. Because the negative up is down. Okay. So V is pointing to the right. And then that means B needs to point into the page in order for the force to be upwards for this part. Which means the total force would be down. Yes, good. So B points into the page. Okay. So then you just set them equal to each other. And so they gave us a velocity. So 1 times 10 to the 7th times B needs to equal 200 over 0.01. Because all we're doing here is we're just setting this equal to this. So we're going to say that QV cross B is equal to QVD. Ontario. Okay, QVD. Okay, so Q's cancel. And then, okay, so B, so 200 divided by 0.01 is going to be 20,000. So 2 times 10 to the 4 over 1 times 10 to the 7. So you can say 1 millitesla, right? Because or 2 milliteslas. 2 millitesla. Because that's the same thing as 10 to the minus 3. Cool? I think we're good. All my Canada people. Nice. Welcome.
That's dope.
Nice. Good question, Gladiator. Looks good. Nice. Okay. Cool. All right. I'm out of time, so I do got to go. But let's close out the stream. All right. Thank you, everyone, for coming to office hours. I appreciate it. Yeah, pineapple. Yeah, solid state batteries are just bad for the environment. It's just all the rare earth materials that are needed for solid state batteries are just very they're just bad. Oh wow, you're doing physics here. Oh, this is cool. Thank you, Narosky. I'll post these. Let me post.
This is Hollow Man's question. I don't know how to continue now after like this. Maybe it's helpful.
Okay. So Holloman, Narosky has helped you out a little bit. So yeah, if you're in the Discord, please go join. That's the best place for us to give you help, and that's where I post all the solutions for everything. I did not do the integral one zap. Sorry, I ran out of time. But I can try to do it next time. I'll take a look at it. It's in Discord. If it's in Discord, it's cool.
There wasn't any integral. That's the thing.
He posted it under the one zap post. Let me find it. Sorry, I gotta go find it. Some stuff.
Oh.
2 + 2 = 4. No, I think
somebody
he.
did it for you.
Well, that was his question. I think he did it and he wanted to
Oh.
show me like how it works.
Oh, okay.
Yeah, this was his. I'll just show it. So people can look at it.
Okay.
This was his original question, which I didn't really understand what was going on here. It's okay.
Yeah, I don't either.
I think I kind of get it. This is showing that displacement in the x direction doesn't deal with acceleration. I agree with that. I don't know what's happening here. Time is equal to... Okay. Time is equal to distance over velocity. Sure. And then... Oh, I see. And then you're plugging that into time for the y equation. Oh, okay. No, I understand. Sorry, yeah, sorry. I originally thought... When you gave me this, I thought this was an integral. Yeah. So... I see. This is not an integral, right? This is just algebra, which is cool. I mean, yeah. You're trying to integrate it. Oh, why are you trying to integrate it? Integrate it with respect to what? With respect to SX? Okay, but then doesn't SY depend on SX? Right? Oh, if it would give me the area under a parabola graph. Oh, I see. I think you want to integrate SY with respect to T. That's the parabola graph. I think I see what you're saying. I see what you're saying. You're saying that like if I had a graph of Y versus X, and then you're integrating with respect to the displacement in the x direction. I mean, that's cool. Sure. I mean, it would get you a parabola, I guess, eventually. Yeah. Okay. Anyways. We can check that out next time. Sorry. I just... There were a lot of questions coming in, and I at first didn't really understand what was going on. Okay. You need help with math tutoring? Yes. So, for anyone, yeah, if you found us here, I know we had a lot of people today. I appreciate everyone coming by to watch. Make sure you go to this website, actualofficehours.com, and that's where you can upload your questions and join our Discord, and then also click here for streaming schedule, because this will have the calendar for all the times we stream. So our next stream is going to be tomorrow. It's starting an hour later, so that's going to be starting at 6 o'clock Pacific, 7 p.m. Mountain, 8 p.m. Central, 9 p.m. Eastern. And then before that, actually, go check out Zach's stream. He's going to be doing some cool stuff, math through tasks. And then I will announce, yeah, if you go join our Discord, I'm going to announce Naroski's going to have a fun stream on Friday where we're going to go over whatever math competition or elegant math he feels like explaining and teaching to me. And teaching to you guys. It's all fun. So, cool. Okay. All right, let's go raid somebody. So yeah, if you're watching us on Twitch, I highly recommend, because that's the best platform, and it has a nice, horizontal format, and you can earn points and stuff. You can teach me about group theory? Sure, I'd love to learn about it. Yeah, I mean, send me a DM. I'm down to like create fun like side streams where we don't just do homework, Yeah, Twitch is great. We love Twitch. We're gonna go raid somebody. Go say hi. Who else is on right now? It is a little bit late, I guess. Oh, physics and depression. I do love physics and depression. He's a great person. Dude, there are actually a lot of people streaming right now. Okay. This is why I asked at the beginning. Well, I have a new job that I have to work 9 to 5, but I was asking ChatGPT, like, when's the best time to strat based on our analytics? And it was like late. I get it. There's a lot of people streaming late. Okay. All right. Go say hi to physics and depression. If you want help with physics, he'll help you out. He's a great guy. Other than that, enjoy. Have a wonderful rest of your Monday. We will see you tomorrow. Peace.
Sometimes I'm not going to be familiar with
thanks,
them.
Naroski. That was fun.
I'm just not going to know them by name. We have T of S maps onto I, where the transformation or transform of state maps onto identity. Actual education, hello, welcome, thank you for the raid. Let me give you a shout out because I always forget to do that. And I don't feel like timing you out today. But let me know how your stream was when you feel like it. Primitive, relate, the capacity, bedrock, identity, self, combine, this, that, arrange, in order, collapse, join, meet, permute, add to model, remove from model, query, learning, time, what emerges, the implementation, quick start, not get, add, stage, commit, push, add, I, staging area, none, push, pull, sync, bidirectional, central, remote, peer-to-peer,